Okay, welcome to this final calculator revision video then towards your GCSE. Again, this is going to be a calculator paper as we've mentioned, and the same things that I said at the start of the last video are going to apply to this one. The big one here being you must show all of your working out, which is why I'm highlighting this on the front of the exam paper here. You're going to pick up so many marks in this exam by showing working out, so do not leave anything blank, and anything that goes onto your calculator screen, make sure you write that down. And I've started the video with that because I want to stress that as being so important for this video. Now, this is probably the longest video I've ever made, so there's an awful lot of revision here, and I appreciate that it is a very long video, but there is just so much content and so much that can come up in this final exam. It's so important that you make sure you cover as many bases as possible. Now, well done if you're coming out of another exam. Obviously, you've done your non-calculator exam and you've probably just done your paper 2 as well. So if you are doing your paper 3 exam for this one, this is who it's primarily aimed at the moment, then well done, because you've finished 2/3 your exam, and they are tough exams, so you should feel really happy with yourself and ready to go into that final exam. Now again, if you have come out of even 1 or 2 of those exams not feeling the best, then you have this paper now to make up for that. So that's why this video is a nice long one, because there's so much content in here. Now what I have done in this video is I have really spent a lot of time putting this one together. There's loads of topics in here, or styles of questions that weren't in the previous 2 videos, and some additional topics and additional question styles as I've mentioned. So there's an awful lot in there. Now, as I mentioned at the start of video 2, there is a specific way that I want you to use this video, so I'm going to show you that now. So as you can see, when using the video, I have time-stamped every single question into its topic name. So when you pause the video, or even before you pause it, it just says down the bottom of the screen there on the video what the topic's name is and the timestamp that it's at. Now if you scroll down into the description and have a look for that timestamp, which we can see just there at 40 minutes and 52 seconds, you can see that's where product of prime factors starts. Now next to that there is a link there to one of my videos where I go through the full description on that topic. So if there is a topic that you come across that you think, wow, that was not enough information there for me to properly understand that, then please do go into the description and have a look at that topic, as you now have a few days until that next exam. Now, as I said before as well, I did say I'd make this video if we hit 500 likes on that video, and you absolutely nailed that. We got 566, so thank you so much to everybody that did like that video. And again, thanks for all the amazing comments. It really does help to sort of inspire the next video to go on, because this took absolutely hours to make. So thank you so much to everybody, and let's go back to the start of that paper. So as I said, make sure that you show all of your working out throughout this exam, make sure that you write everything that goes on your calculator screen onto your paper, and make sure that you remember all of those key formulas that we talk about in this video: speed, distance, time, mass, density, volume, the area and circumference of a circle, how to work out the volume of a shape by finding the cross section, how to convert units, all of these little things that you need to remember. Just go over those, write them on a revision card, and make sure that they are imprinted in your mind in those few seconds before you go in. But anyway, good luck on your exam. I certainly do wish you all the best of luck, and please do leave comments later on in the year when you do get your results back, and let me know how you've done, because it's always really nice to hear that people have obviously had all their little success stories and how this channel has helped them. So there we go. With that being said, let's get started. So 0.34 has been rounded to 2 decimal places, right down the error interval. Now again, I'm just going to put an X in the middle, and I'm going to put my arrows pointing left. We know that this one's going to have our equal to symbol on it. I just need to find, and I'm going to label it upper bound for U as UB and lower bound as LB, and I use this quite a lot. So to get our upper bound, which is the one I always start with, all I'm going to do is I'm going to stick a 5 after the 4 there. So it's 0.345. And there we go, there's our upper bound done. Now to get our lower bound, we just need to drop the 4 down to a 3, the last number there up in the 0.34. So it's 0.33, dropping it down, and then again stick a 5 on the end. And there you go, that is your error interval done. So it's 0.335 and 0.345. Okay, and that's your final answer, and there's your error interval done. Okay, here it is. So it's about an alarm clock. It says alarm A sounds every 20 seconds, B sounds every 45, and C sounds every 120. It says the alarms start going off at the same time. How many times in 1 hour will the three alarms go off at the same time? So we've got three numbers here, so you'll have to do a list of three numbers. I'm going to go over the answers, but have a go, see what you get, see how far you get, and we'll go over the full answer in just a sec. Okay, so 20, 45 and 120. Let's have a look. So 20, 45 and 120. So if I start doing lists, I have got 20 and 120 there, so it's definitely going to end in a 0. So if I start with a 45, 90, 135, add another 45 gets us to 180. Now that ends in a 0, 20 goes into that, but 120 doesn't, so I'm going to keep on going. Now I can use a little bit of logic here. I know that it's going to go up every 90. I'll keep going though, so 225 and then 270. 120 doesn't go into that, so I'm going to need to keep going again. So let's add 45 again, we get 315 and then 360. Right, so 120 definitely goes into 360 because we get 240 and then 360, and 20 definitely does. I'm not going to write them all down, but if we kept on going, we would get down to 360. So we found a match there for our lowest common multiple, 360. So what does it actually say? It says they start going off at the same time. How many times in 1 hour will they go off at the same time? So that's in an hour. This is in seconds. So how many minutes is that? So 360 seconds, if we divide that by 60, that gives us every 6 minutes. So 360 seconds equals 6 minutes. Okay, so in terms of how many times will they go in 1 hour? Well, if they go off at the same time every 6 minutes, they'll go off at 0. They'll go off again at 6, they'll go off again at 12, they'll go off again together at 18, 24, 30, 36, 42, 48, 54, and then on the 60th minute on that final part of the hour. So let's have a look and see how many there are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they'll go off 11 times together. How many times in 1 hour will the three alarms go off at the same time, on the start of the hour and on the end of the hour? And that will be 11 times. So our final answer here would be 11 times. So the rules for standard form that we have, we're going to have a number. So let's just make a random one up, something like 2.5 times 10 to the power of, that's not a 10, 10 to the power of 3. So this is what something in standard form is going to look like. Now the rules are, the number at the start here has to be between 1 and 10. So between 1 and 10. And it's always times 10 to the power of something. Now 10 cubed here in this little example is 1,000, 10 times 10 times 10. So this would actually create a little number here, but it's always times 10 to the power of something. So we're going to have a look at how to write this number up top, this 3,400 in standard form, making sure that we follow these rules. So 3,400, if I was to hop a decimal in from the top, so I'd have to go 1, 2, 3, and that would make 3.4. So 3.4 is between 1 and 10. I couldn't have 34, I couldn't have hopped it over again and had 0.34 because that wouldn't have been between 1 and 10. So 3.4 is between 1 and 10. So it's 3.4 times 10 to the power of, and all we have to do is count how many little jumps we did there, and we did 3 jumps, so that would be 10 to the power of 3. And that's our final answer, writing it in standard form. Thinking about what this means, that means 3.4 times 10 times 10 times 10, which is times 1,000, and 3.4 times 1,000 is 3,400. So all we're doing is writing it in a standard format. It's a little bit shorter, particularly if we have a lot of zeros after there. Let's have a look at another one. Okay, so a slightly different number. We've got a small number here. We've got 0.00345. So there's only going to be one ever so small change in this one, and we'll have a look at what that is. So to make this a number between 1 and 10, we've got to hop the other way this time. We've got to hop that decimal 1, 2, 3 places to make it 3.45. It's still going to be times 10, but we can't have a number here that's positive, because timesing that by 10 would make it larger, timesing it by 10 squared again would make it larger. So to indicate the fact that this is a little number, a small number, we're going to still have a look at how many jumps we've done there, but we're just going to put our power as a negative, so -3 for those 3 hops, and that just indicates there that it's a small number, it's less than 1, and we're going to have to hop it the other way to actually find out what that is. So that is 3.45 times 10 to the -3 when it's a small number. Okay, so that is important there. When it is a small number, a 0-point number, it is going to have a negative power. Okay, write 3.4 times 10 to the 4 as an ordinary number. So going back the other way this time, an ordinary number is just an ordinary number like we were writing down before, but we've been given this in standard form. So I'm going to write this down. What we've got is 3.4. Now, it's asking us to do times 10 to the power of 4, so we know it's going to be a big number and not a little number because it's a positive power. And that 4 is going to represent 4 jumps or 4 hops. So let's hop this out 4 places, making it a bigger number. So to the right, 1, 2, 3, 4. So underneath all of these little loops, I just need to tidy this up and put those zeros back in, because my decimal would end up just there. So that's my working out. Let's write this out nice and neat. So we've got 3, 4, 0, 0, 0, so 34,000, and that's what this is as an ordinary number. Let's have a look at another one. Okay, 8.03 times 10 to the -5, so it's a -5 there in the power, so it's going to be a 0-point number, so I'm going to have to hop it the other way this time. So let's write out what we've got so far. We've got 8.03. So the decimal is already drawn in for us, it's just in there. So we're going to hop it from there to the left to make sure it's that 0-point number, because it's a -5 as the power. And we're going to do 5 hops. So 1, 2, 3, 4, 5. And then let's fill in these zeros and put that decimal in there where it's going to go now. Now we've got this number here. Obviously we just need to tidy this up because we would normally write this with a 0 at the front. So tidy that up with a 0. And let's rewrite actually what we've got here. So we've got 0.0000 and then 803, and that is my final answer there for writing that as an ordinary number. So this says find the highest common factor of 24 and 64. So a factor being a number that fits into these two numbers perfectly, and we're going to try and find the one which is matched in both. So I'm going to start with finding the factors of both these numbers. So I'm going to start with 24, okay, and then I'll have a look at 64. So I'm going to split this up into 2 halves. So 24, now the first 2 factors I always find is 1 and itself, so 2 and 24. And then looking at the 1, I always go 1 number higher, so I'll go for 2. I'll go for 2 and 12, and it's a really nice method of doing it because it starts to limit the amount of factors for each number. So in that first choice here, when I got 1 and 24, I'm only concerned with all the numbers between 1 and 24. But now I've got 2 and 12, I'm only going to look at the numbers between 2 and 12. So I'm going to start with the next number 3. 3 does go in, goes in 8 times, 8, 16, 24. And now I only need to look at the numbers between 3 and 8. So the next number 4, 4 goes in, it goes in 6 times. And now the only other number I have to choose from is between 4 and 6, and that number's 5, and it doesn't go in. So there we go, I'm happy I've got all the factors there. I've worked through it in a nice process there. Moving on to 64, we've got 1 and 64. 2 times 32. Now does 3 go in? Again, nice little trick here. Add together the digits in 64. So 64 over here, if we add together 6 and 4, 6 plus 4 is 10. And 10 is not, oh that's not a 10. 10 is not in the 3 times table, so it doesn't divide by 3. There's a little trick for seeing if something divides by 3. So I'll move on to the next number, 4. 4 does go in. Not very nice here. If you can't work that out, let's just do a little division. So 4 into 64 goes once, remainder 2, and it goes into 24 6 times, so it goes in 16 times. Quite a nasty one to spot there. So now I've only got the numbers between 4 and 16. 5 does not go in. 6 does not go in because 6 gets you to 60 and then 66. So 6 doesn't. Does 7 go in? No, it's 6 less than 70. 8 goes in, no doesn't it? It goes in 8 times. There we go, so it'd be 8 times 8. Now I don't need to write down both of those now because I'm finished. There are no numbers between 8 and 8, no whole numbers that we're looking for, so we'll get rid of one of those 8s. And there is our factors. Now let's have a look. Which is the highest number in both? Now I'm going to start over here with a 24. So 24 doesn't go in, so not that one. 12 didn't go into 64, so not that one. But 8 being the biggest number here, look, does go into both. So our highest common factor there is 8. So I'm going to abbreviate highest common factor to HCF, and I'll just say the highest common factor equals 8. Okay, so simplify this. 15 minus 4x minus 9 plus x. Let's have a look at what we get here. So the numbers I'm going to start with first, as is a number first, although you don't have to. So I've got 15 and a minus 9. And 15 take away 9 is 6. Positive 6, so I'll just write 6. Okay, so that's what those two came down to make. Now I'm going to look at the x pieces here. We've got negative 4x, add x. Now if there's not a number in front of it, that's 1x. So we've got minus 4, add 1. Minus 4, add 1 is minus 3. So minus 3x is there. And as it is minus, I need to make sure I emphasize that it is negative. So negative 3x. And we get 6 minus 3x there as our final answer. Okay, so if you rewrite this, you can put little circles or little boxes around the pieces, but just make sure you have a look at what symbols are in front of them, if it's positive or negative, and make sure that they go alongside that piece. Okay, here we go. So we've got some x squared pieces and some x pieces. Now, although all the pieces have x in, these x squared pieces we're going to treat separate to just the x pieces on their own. So if I just have a look at the x squared pieces, we've got a 12x squared, and we've got a minus 3x squared. So 12 lots of x squared, take away 3 lots of x squared, leaves us with 9 lots of x squared. And I'm just going to leave that piece separate to the x parts. So looking at the next one, we've got 5x, take away 2x, and just like we did before, 5 lots of x, take away 2 lots of x, leaves us with 3 lots of x, and that's positive 3 lots of x, so plus 3x. And there we go, we'd leave it just like that. We can't join up an x squared and an x piece, they stay separate. Okay, so expand and simplify this. Now I've got this minus 2 in the middle here, so we just need to be careful, but let's just treat it in exactly the same way. We'll times the first bracket by 3 to start with, so 3 times 2x gives us 6x, and 3 times negative 4 gives us negative 12. Now let's have a look at that second bracket. So we have a negative 2 at the start here, so we're just going to have to remember to times by negative 2. So negative 2 times x is negative 2x, and negative 2 times positive 5 gives us negative 10. Okay, so the symbol's not just getting copied there, it is getting affected by that negative 2 at the start, so be very, very careful with this negative 10 here when you're doing these. Right, so collecting it all together, we've got 6x, take away the 2x, and that leaves us with 4x's. And we've got negative 12 and negative 10 here, negative 12 take away 10 is negative 22. And there's that expanded and simplified. Okay, so in this question we have coefficients of x going on that are bigger than 1. So we've got 2x, coefficient just meaning the number in front of the x. So we've got 2x minus 3 and 3x plus 4. I'm going to do exactly the same approach though, so I'm just going to rewrite these so it's a little clearer. So 2x minus 3 and 3x plus 4. Okay, right, so on to the first two. 2x times 3x, so we're still going to get an x squared, but the number multiplies the number there, so 2 times 3 is 6, so we get 6x squared instead. Then doing the same thing again, so 2x times 4, 2 times 4 is 8, so plus 8x. And then onto the underneath, just like we did before, negative 3 times 3x is negative 9x, and negative 3 times 4 is negative 12. So we do get some slightly larger pieces in these in terms of the coefficients in front of x, but exactly the same process. So we still have a 6x squared. We just need to tidy up these two middle ones, just like we did before. Now 8 take away 9 is just 1. So remember when you write 1x, you don't put the 1 in front of it. You can do it, it's not, you know, we don't tend to write the 1 in front of the x there. So I'm just going to put minus x, which just means minus 1x, and then minus 12. And there is your double bracket expanded here. Okay, so this question says factorise fully. And that normally means because there's two factors that can come out. So let's have a look. We've got 12x squared and we've got 10x. Now straight away, they've both got an x in and they've both got a number. So let's just look at the numbers to start with. So numbers that go into 12 and 10, our only option there is 2. So we can definitely take a 2 out. But there's an x in both as well. So we can also take an x out. Okay, we're just having a look at what goes into both. 2 goes into both those numbers and x goes into both the letter parts. So 2x on the outside, open the bracket. Now what do we multiply 2x by to get to 12x squared? Well, from 2 to 12 we have to times it by 6, and to make sure we get the x squared as well, we've also got to put an x in there. Again, just copy the sign, we finish with that piece. How do we get from 2x to 10x? Well, from 2 to 10 is 5. So times that by 5, but we don't want to put an x in with that piece because we don't want an x squared up here, just the 10x. So that's that one finished. There we go, 2x brackets 6x minus 5. We've got negative 2x in the middle and negative 15 at the end. So let's draw our brackets and think about what numbers times to make 15. So we've got 1 and 15, or 3 and 5. Now we've got negative in both of these, so the only options I can have to get a negative 15 at the end, I've got to have one that's positive and one that's negative. Okay, otherwise we're not going to get a negative answer at the end. So let's have a think about that while we're doing it. So 1 and 15, there's no way I'm going to make negative 2 out of those two numbers. 15's too large, pairing it with the 1 there, so it's not 1 and 15. But I can make negative 2 out of 3 and 5. Just got to be very, very careful here the way that I get it round, because I can either have negative 3 and positive 5, or I can have positive 3 and negative 5. So just got to think, in order to get negative 2, the pairing that I want to do is I want to have 3 take away 5. So I want to have plus 3 take away 5, and that would allow me to get negative 2. So I just need to stick those numbers in, plus 3 minus 5. And when you've got this option with the positive and the negative, do make sure that you double check, just thinking to yourself in your head, plus 3 take away 5, does that definitely make negative 2? Yes it does, so we're happy with that one. So when it comes to solving a quadratic, the way to solve it is we have to factorise it. And we can only factorise it, and we'll discuss this a little bit more, when it is equal to 0. So sometimes they won't be equal to 0, but particularly in the foundation level style questions, they're always going to be equal to 0 here. And if they're not, we'll have a look at how to obviously just rearrange them slightly in a later question here. But when it comes to this here, all we're going to do is we're going to have a look at that quadratic there. So we've got x squared plus 7x plus 12. Now when we're factorising one of these, they go into a double bracket. And all we do need to do is have a look at this number at the end, which is 12, and we have a look at what numbers multiply to make 12. So we could have 1 and 12, and again I'm not going to talk about this too much because I'm going to link the description for factorising quadratics, but we can have 6 and 2, and we can have 3 and 4. So we just need to figure out what combination of numbers are going to go into our double bracket. So we'll put our double bracket here, it's all equal to 0, and we've got an x at the start of both brackets. So obviously we're looking at that number in the middle there, the coefficient of x, which is positive 7. So the two numbers that are multiplied to make 12 and also add to make that positive 7 are our 3 and our 4. Okay, so we're going to put 3 and 4 in our bracket, and that would be plus 3 and plus 4. There we go. Now in terms of obviously our solutions here, now you don't really need to know this for this question in particular, but if this was a quadratic equation, a line equation, sorry, it would relate to a quadratic curve. Okay, now I'm going to draw what this would look like. It looks something like this. Okay, there we go, not to scale there, but it looks something like that. Now when we are looking at the solutions here, we are looking for essentially where this curve crosses through the x-axis, and that's what equal to 0 is representing there, and it's in a kind of very simple level. Equal to 0 kind of means ground level. It means where y is equal to 0, and if you think about the y-axis, the y coordinate just here, we've got y equals 0 just down there. So we are having a look at, on this graph, where does the quadratic curve cross through the x-axis when y is equal to 0. Now there's a little trick with these brackets, but in terms of obviously explaining how we go about getting our solutions here, we just say, okay, well when does this bracket here, x plus 3 equal 0? And if we write that out, when does x plus 3 equal 0? And if we take away 3 from both sides to solve that, we get x has to be equal to negative 3. And if we do that for the other one as well, if we do that for this one just here, we say, okay, well when does x plus 4 equal 0? And again, if we solve that and take away 4 from both sides, we get x has got to be equal to negative 4. So there we go. If I label that on the graph here, we've got minus 3 and we've got minus 4, and that's how I knew what the graph would look like. But there we go, there's our two solutions, x is negative 3 and x is negative 4. But if you have a look at the bits in the brackets there, obviously we've got a plus 3 in the bracket, and our solution ended up being negative 3. And on the flip side, on the other one, we had plus 4 in the bracket, and our solution ended up being negative 4. So obviously it's important to know how to do this little process here, setting them both equal to 0 and solving it for some of the harder ones. But in terms of just getting through these questions nice and quick, once you've factorised it, all you have to do is flip the symbol in the bracket there. Okay, so work out the value of 2x plus 3y when x is negative 4 and y is 5. And this is where I find writing these brackets really does start to help now. So 2 lots of negative 4, 2 lots of negative 4, add 3 lots of 5. And again, now we can get rid of the brackets now that we've substituted them in. So 2 lots of minus 4 is minus 8. I'm going to add to that 3 lots of 5, which is 15, and then we just need to complete the sum, so negative 8 add 15 is 7. So our final answer there is 7. So we've got two equations here, and simultaneously just means we're going to be solving two of them together at the same time. So in both of my equations I've got an x and I've got a y, and we've got to find the value of both of them. So I've got two equations here. I've got the first equation, which I always just label equation 1, and it's a good little tip here just to label them up. So we've got 3x plus 2y equals 4, and the second one here we've got 4x plus 5y equals 17. Now if we can get one of the letters to be the same value or the same coefficient in front of them, then that is going to help us to then eliminate one of those variables. Now we'll have a look, because we've got the x's at the front, which we can underline, so we could make those the same, or we could make the numbers in front of the y the same. Now it's just personal preference, but I've always just looked at that y value there, the one in the middle. Okay, and I'm going to explain that a little bit more as we go through it, but I'm just going to make the numbers in front of the y there the same. So in my head I'm just thinking, well, 2 and 5, they can turn into 10. So the top equation, equation 1, if I was to times everything in that equation by 5, then the number in front of y would be 10. So I'm going to times that top one by 5. And the one below it, the equation with the 5y there, I'm going to times that equation by 2, and that'll also allow me to get a 10 in front of the y there. So what I'm going to do is, to the side, I'm just going to completely rewrite both these equations, but I'm going to times the top one by 5 and the bottom one by 2. So if I times the top one by 5, we get 15x plus 10y equals 4 times 5, which is 20. And the one below that, timesing it by 2, we're going to get 8x plus 10y, and 17 times 2 is 34. Now I have two options now. I can add these equations together, or I could subtract them from each other. Now if you think about 10y and 10y, if I was to do 10y add 10y, that's going to make 20y. So they're not going to disappear if I add them together. But if I do 10y take away 10y, then that is actually going to eliminate them, and they're going to disappear, and we're not going to have any y's left in our equation. So the way to remember it is, and this is just personally how I've always remembered it, is these little signs here in front of the y's. If the signs are the same, you subtract. So the SSS rule, some like to call it. So same signs subtract. This is going to change if the signs are different. If the signs are different, we're going to add, and we're going to have a look at why we do that when we actually have different signs there. But if they're the same signs, subtract them away from each other. So all I'm going to do is I'm going to take them away from each other. So I'm going to put a little minus sign here, and I'm going to do the bigger equation take away the smaller equation. Now, obviously we've got some different numbers going on here. We've got a bigger number at the end in the second equation, but we've got a bigger x value here in the top one. So it doesn't really matter which way we do it. I'm just going to go for the top equation there, and I'm going to take away the one below. So 15x take away 8x's leaves me with 7x's. The 10y's are gone. 10y take away 10y is 0. They're gone. That's the whole point of what we're trying to do here. And then we've got 20 take away 34, and 20 take away 34 is negative 14. So we've got 7 lots of x, 7 lots of whatever x is equal to negative 14. So in order to solve this, to find out what 1x is, we're going to divide by 7. Just normal solving equations here, and we get the value of 1x therefore has to be equal to negative 2. Negative 14 divided by 7 is negative 2. So there is our first answer. We've got x equals negative 2. Now in order to solve this, we also have to find out what y is. So we just need to substitute this value of x into one of these two original equations up here, 1 or 2. Now it doesn't matter which one you choose. I'm going to choose to sub it into 1, not for any reason, because they both look very similar equations, but I'm just going to sub it into equation 1. So I'm just going to write that down. I'm going to write sub x equals negative 2 into, I'm not going to write equation 1, I'm just going to put 1 there. Okay, so it's quite nice once you've labelled it up, you can just shorthand write in a lot of these things. So subbing it in, we've got 3 lots of x, I'm just going to circle that here at the start, 3 lots of x, so 3 lots of this negative 2, 3 lots of negative 2 is negative 6. And you can write this working out down if you want. I just think that one's okay just to do in your head. So 3 lots of negative 2 is negative 6, plus the 2y equals 4. And now we just need to go about actually solving this. So we've got negative 6, add 2y equals 4. So just like normal solving equations here, we want to get rid of this negative 6, so we can add 6 to both sides. And if we add 6 to both sides, we get 2y equals 4 plus 6, which is 10. And then solving that just like we did with the x value, dividing both sides by 2. So divide by 2 to get the value of 1y, and we get y equals 5. There we go. So we've got our value of x, same sign subtract, made the coefficients of y the same. We've got our value of x is negative 2, subbed it into equation 1, although we could have subbed it into either, and then we solve that again to get our value of y. Let's have a look at another one where there's an add and a subtract in our two equations. Okay, so here we have two more equations where we've got a negative in there. We've got 3x minus y equals 4 for equation 1, and we've got another equation with a positive, so 2x plus 4y equals 26 for equation 2. Lovely. So again, I'm just going to have a look at these y values, these y coefficients, the number in front, and we're going to try and make them the same. This is quite an interesting one because in fact I don't really have to change both here because I can make that a negative 4y on equation 1. So all I'm going to do is I'm just going to times equation 1 by 4, and this happens sometimes where you only actually have to change 1, sometimes we have to change 2, but in this case I can make it a 4 there. Now it doesn't matter that it's negative 4, I don't have to try and match it to make it positive 4, I just have to make the number the same, the actual 4 part. Okay, so I'm just going to make it negative 4 in front. So if we times that all by 4 and rewrite it, 3x times 4 is 12x minus 4y, and 4 times 4 is 16. There we go. And then we're not changing the bottom one, so all I'm going to do is rewrite that below so that I've got these grouped together. So 2x plus 4y equals 26. Okay, there's my two equations. Now we subtracted them before, but if I think about this logically, if I was to do negative 4, the one on the top, and then subtract positive 4, so take away 4, I'd end up with negative 8. So those y coefficients, or those values of y, are not going to disappear because I'll have negative 8y if I was to do that. So let's get rid of that because we're not going to actually be able to subtract these. So when the signs are different, we're going to add. So different signs, add. Okay, so when they have same signs, subtract, different signs, we're going to add them together. So let's write that. So 12x add 2x is 14x. Negative 4y add 4y is going to go to 0, they're going to disappear. And then 16 add 26 is 42. There we go, not the nicest one here, particularly if it's non-calculator, but 14 does go into 42 a nice amount of times. It goes in 3 times, so dividing by 14 gets us x equals 3. And there's our first value. So not negative this time, quite nice to sub that back in. So if we sub that back into an equation, let's pick one. Sub x equals 3 into, and you can pick one at random. Let's sub it into equation 1 again. Let's have a look and see what we get. So let's sub that in. So x equals 3, if we sub it into 3x here, 3 lots of 3 is 9. So we get 9 minus y equals 4. Now you can do this logically. You could think, okay, well 9 take away something equals 4. That number has to equal 5, doesn't it? But if we solve it just like normal, let's get rid of this number so that we know the answer is 5. But let's have a look. Let's take away 9 from both sides, and we get minus y, negative y, equals negative 5. 4 take away 9. And then therefore positive y has to equal positive 5, or we could divide both sides by negative 1 or times both sides by negative 1, but ultimately there we are going to get the opposite value. If negative y equals negative 5, then positive y equals positive 5. Okay, which we knew logically from the start here. When if you look at that, you've got 9 take away 5 has to equal 4, doesn't it? So we've got x is 3 and y equals 5. Okay, so this question says work out the value of x, and what we've got here is we've got some algebraic angles. So we have 2x, x plus 18 and 2x plus 7. Now this is going to be very similar to one of the first questions we looked at in terms of we're going to make a linear equation here with x on one side, but it doesn't explicitly give us a number to set our expression equal to. So this is going to be testing your angle facts and just knowing that angles in a triangle add to 180 degrees. And we know that these three angles here have to equal 180. And that's what's going to be involved in some of these angle questions here, testing that obviously that knowledge fact there of what these angles add up to. So if we add these all together, we can set that equal to 180. So again, if we count at the x's, we've got 2 there, another one there, that's 3, and then 2 more there, so that's 5x in total. So we have 5x, and if we add up the numbers there, we've got 18 and a 7, and 18 adds 7 is 25, so we have 5x plus 25, and that is going to be equal to 180 degrees. So there we go. We started off by creating our expression for the angles, or the sum of the angles within the triangle, and then we finished it off by setting it equal to the 180 degrees using that knowledge fact that we already know. So solving this then, we can take away the 25 from both sides, and I haven't really been doing this on some of the previous questions, but it's always good just to show that little bit of working out there, what you're actually doing. So take away 25 from both sides, and 180 take away 25 is 155. So we have 5x is equal to 155. And then to finish that off there, we just need to divide by 5, There we go, and 155 divided by 5 is 31. Now obviously if you have a calculator, little bits like that are nice and easy to do, but if you don't forget that you obviously can just do a little bit of bus stop to the side. You can always do your working out to the side there just to work those little bits out. So there we go, x is 31, this is in degrees, so x is 31 degrees, and there's our final answer to finish off this question. Okay, so obviously in this one here, we are forming a linear expression with x on one side, but we're actually picking the number there out of our actual knowledge of angles within shapes. So just bear that in mind for some of these questions. Okay, so we've got these worded questions here, and you might recognise some of these questions as well in terms of the style that you might have seen these come up in little exams or little tests that you've done. So we've got Amy has some sweets. Bethany has twice as many sweets as Amy, and Charlie has 5 more sweets than Bethany. In total, they have 55 sweets. How many sweets does Charlie have? And at first, these sort of worded questions can seem a little bit confusing. It might seem that you have to just apply a bit of logic or guess some numbers, but there's a nice way that we can do this by forming and solving an equation. Now what we're going to do is we're going to allocate the letter, and we may as well use the letter x as we've been using that for the rest, but we could use any letter if we wanted. We're going to allocate the letter x to one of these people. So we have Amy, and I'm just going to write these to the side. We have Amy, we have Bethany, and we have Charlie. Now if we look at our statement here, one of these people we haven't been told anything about. So it says Amy has some sweets, it says Bethany has twice as many as Amy. So we've been told something about Bethany, she's got twice as many as Amy. And we've been told that Charlie has 5 more sweets than Bethany, so we've been told something about Charlie as well. But the person that we haven't been told anything about there is Amy. Okay, and Amy's kind of like our little odd one out there. We've not been told anything about her. So if we look at Amy, and we're going to just give her that letter, we'll call her X. Okay, we don't know how many sweets Amy has, but we know how many sweets everyone else has in relation to Amy. So if we look at that first line, it says Bethany has twice as many as Amy. So if Bethany has twice as many, she has basically double what Bethany has, so we could call Bethany 2x. Okay, and 2x just means 2 times x. Whatever Amy has, 2x would double it. So there we go, there's our expression for Bethany. Now if we look at Charlie, it says Charlie has 5 more sweets than Bethany. So Charlie has 5 more sweets, exactly 5 more than what Bethany has. Now Bethany's was 2x. So we're not going to times it by 5, it's just 5 extra sweets. So Charlie is going to be Bethany's 2x plus an extra 5. Okay, obviously if it had 5 sweets less than Bethany, we'd have 2x minus 5, but it's 5 sweets more than Bethany. So there we go, we've got 2x plus 5. Right, so we've got our 3 expressions for each person, and now we can actually have a look at forming our equation. Just as a little side note, obviously some of these descriptions could be given to you slightly differently. We could have been told that Charlie or somebody had 5 more than Amy, and then so-and-so had twice as many as that person, and that would just mean doing it in a slightly different order. For example, I mean, if it said Charlie had 5 more than Amy, then Charlie would instead be x plus 5. It might then say that Bethany had twice as many as Charlie, and I realise I'm saying quite a lot of different words here, but then we would have to double the x plus 5. So we could have these in different orders, but this is just one type of example and one type of question. So obviously what we need to do is now think about how we're going to form our equation. We've got the expressions for each person, and now it says in total they have 55 sweets. Or in other words, if we add together all these expressions, they are going to add up to 55. So if we add them all together, we've got x, 2x and 2x, that's 5x, and we've got the plus 5, so we've got 5x plus 5. And that is going to be equal to the 55 sweets. So if we write our equation then, so 5x plus 5 has to equal 55, and then we can just go ahead and solve that. So take away the 5 from both sides, we have 5x equals 50, and then we can divide by 5, and we get x equals 10. And then we can use that x equals 10 to find out how many sweets they all have, and we can just use it based on the expressions that we've got over there. We now know that Amy is x, so Amy's got 10. Bethany has double that, so Bethany's going to have 20. And Charlie has 5 more than Bethany, so Charlie will have 25. And just double checking there, they all add up to 55, and they do. So in terms of this question, how many sweets does Charlie have? Charlie has the 25 that we've got just there. Right, there we go. So that's how to go about some of these questions, and I think it's good for this question here. Although we could have just substituted 10 into Charlie's expression end and 2 times 10 plus 5, I always think it's good just to find out how many all of them have, or whatever the question's about, and then just pick the one that you need for this particular question. So as it's asked about Charlie, obviously we only need to give the 25 there as our answer. Right, so for our next one we have a rectangle, and here's where a different type of linear equation is going to get involved, and we're going to have a look at why. So it says here, work out the perimeter of the rectangle. So it doesn't explicitly say in this particular question, work out the value of x, but in order to work out the perimeter, we're going to need to know what that value of x is. Now it doesn't actually tell us any information, it doesn't tell us what the perimeter is, it doesn't mention the area or what the area is. So we've not been given any numerical value to set our expression equal to. So in this question here, if we were to add up all of these side lengths, which we could do, we could create an expression for the perimeter, but if we added them all up, and let's just have a quick look, we've got 4x, 2x and another 2x's here, that would add up to 8x in total. So we could write that out, we could say okay, 8x, and then add up the numbers, we've got a 1 and a 12, so plus 13. Now we can do that, that gives us an expression for the perimeter right there, 8x plus 13, but we've got nothing to set it equal to. So that's not going to work for us in terms of this question, we've got no equation that we're able to actually form. So we're going to have to approach this in a different way, and this is kind of looking at your ability to just look at a shape and think about what do you actually know about a rectangle, and basing it off that knowledge. So let's get rid of that. Now what we know about a rectangle, other than the fact that obviously all the angles are 90 degrees and we've got 4 sides, we know that the opposite sides in a rectangle, oh, there we go, are equal. Okay, we know that these sides here are equal. So there's two equations that we can solve there. We can set the left and right hand side equal to each other, and we can set the top and bottom equal to each other. Now if we do set the left and right equal to each other, we've got x equals x. So that's just a statement really. We know that x equals x, so that one's not going to be any good to us. But the top and bottom, we can definitely set that equal to each other, and that's going to form an equation right there. We've got 4x plus 1 on the top, let's just highlight that, and that has to be equal to 2x plus 12. So we can form an equation just like that, and let's see what that gives us if we write that down. So if we write that down, it's got 4x plus 1, now it doesn't matter which one goes on which side, but 4x plus 1 equals 2x plus 12. There we go. Now to be fair, what I have done there is I've actually put the the bigger value of x on the left there. I just prefer it being on the left, but when we solve it we get our x pieces on the left, but it doesn't actually matter either way. We can put those on either side. So we've got 4x plus 1 equals 2x plus 12. Okay, all we're doing there is we're making the statement that the opposite sides are equal. So we can go ahead and solve that. And again, obviously, I'm going to assume knowledge on this that you already know how to solve these. We need to subtract or get rid of the smallest value of x from both sides, which is the 2x. So if we delete essentially 2x's from both sides, we end up with 2x plus 1 on the left, and that's going to equal the 12 that we have left over on the right there. You just need to be careful sometimes, because when you do get rid of these, sometimes it might have negative 12 over here. It doesn't in this case, it is positive 12. So there we go, we don't need to worry about putting the symbol in there. Now we can subtract 1, so 2x is going to equal 11. And then we need to just solve that by dividing by 2, and in this case it does give us a decimal. If we halve 11, I'm just bearing in mind that sometimes you won't have a calculator for this, and if you don't, you can always write that as a fraction, 11 over 2, and then simplify it from there. In the case of this, I think it's fine for us to turn that into a decimal, but if it is quite a nasty one sometimes, which it can be, you can actually just leave it as a fraction, but 11 divided by 2 is 5.5. There we go, so we have 5.5 centimeters, and to be fair, it doesn't actually give us any units in this one, so we'll leave the centimeters out this time because it doesn't say anywhere that it's actually in centimeters. So we'll just give our perimeter here in terms of a unit number. There we go, so 5.5 is our value of x. Now this question does say to work out the perimeter, so in the case of this we do actually need to work out all the side lengths and add them all up. So the nice easy ones we've got x on the left and the right, so they're both 5.5, so we can label those both 5.5. And then we're just going to have to work out the top and the bottom. Now, it doesn't matter which one we pick here, we know that the two sides are going to be equal, so I would just decide, okay, well, which one just looks easier to sub my 5.5 into? And I reckon it's maybe the bottom one there, just because we have to do 2 lots of 5.5. So for the bottom, we've got 2 lots of x, so 2 lots of 5.5 is 11, plus the 12, and that gives us a side length there of 23. There we go, so 23 is going to be our bottom length. And to be fair, you can check that on the top. 4 lots of 5.5 is going to be 22, plus the 1 is 23 as well. There we go, so we have all our side lengths. Obviously we are looking at the perimeter here, so we do just need to add those all up. So 23, add 23, add the two 5.5s, and we can do that using a bit of column addition if we want. The two 23s add up to 46, so we'll just write that as 46. The two 5.5s add up to 11, so 11. And if we add those all together there, we get 57. And again, we don't have any units, but we'll just leave our answer as 57. Obviously, a question like this would usually give you some units, but if it doesn't, just leave it in terms of a number right there. So there we go, that is forming and solving equations for when we've got side lengths, okay? So you might have to form a linear equation with x on one side if it gives you a numerical value that you can set it equal to, or if it doesn't, you're possibly going to have to create an equation like this where we have x's on both sides and spotting that concept there of which sides are equal and setting them equal to each other like that. So the next ones, I've got two examples here, both with fractions involved, both with similar numbers. We're going to see how we treat them differently. So this one on the left here, y equals x over 4, take away 8. Now that x is locked in by that divide by 4 at the moment, and whenever we've got these fractions in, it's locked in, but that minus 8 is free for us to move, it's outside of the fraction. So we can get rid of the 8 and then just focus on the fraction to start with. So I can add 8 to both sides as it's a minus 8, so add 8, and we get y plus 8 equals x over 4. Now the only thing we've got left is the fraction, and we can times both sides by 4 to reverse that divide by 4. So the second step here would be to times by 4 just to reverse that divide. And if we times this side by 4, we can open up a bracket and just say, okay, well, it's 4 lots of y plus 8 equals x. And if you wanted to, you could actually expand that bracket. So we could write our final answer as x equals, and we could expand the bracket, 4y plus 32. Okay, you don't actually have to expand the bracket, we could leave it in a bracket, but it's fine to expand it as well. To be fair, we could actually take a different approach here. We could have times by 4 to start with, but if we did, we'd have to remember everything gets times by 4, so we'd just have to remember to times this 8 by 4 as well, and we'd have got negative 32 and then added it over. So there are other ways of approaching it, but it's like that's just the way that I prefer to do it. But there are two ways of actually rearranging that from the first step. Onto this one on the right, slightly different. There is only one step for us to start with because everything on the top here is locked in by this divide by 4. So I'm going to have to times by 4 to start with this time because everything is locked in. So timesing by 4 would leave us with 4y on the other side. So we'd have 4y equals x minus 8. And then I would be able to add the 8 over. So I'm actually forced into doing it that way on this particular question. When we add 8 over, we get 4y plus 8 equals x, and again you can rewrite that if you want, x equals 4y plus 8. Okay, so quite a few different questions there on rearranging. Make sure you've made some notes on them. Just remember everything you do, just reversing what is happening to x. So if that means reading it out, so if we look at this one here, okay, you could read this question as y is x take away 8 and then divide by 4. So the last thing we did was divide by 4, so the first thing we do is reverse that and then add the 8. Right, so we've got some square roots introduced in this one. Now when we've got a square root here, everything underneath it is completely locked until we get rid of this square root. Now the opposite, the way to get rid of a square root is just to square both sides. So if we square both sides, we'll get y squared on the left, and squaring the right hand side literally just removes that square root, so nothing's going to change underneath it. We just have 3x plus 4. So once we've done that, quite nice and easy, it looks quite similar to some of the others. We're going to minus 4 from both sides, and we get y squared minus 4 equals 3x, and then finishing it off just like some of the first ones we did, we're going to divide by 3. So divide by 3, and we get y squared minus 4 all over 3 equals x, or we can just write the x equals at the start. So x equals y squared minus 4 over 3, and that's our final answer there. Just remember that when we've got the square root, everything's locked in until we square both sides. So it says find the 20th term in the sequence, and it starts to give us the start of a sequence. And obviously what we could do is just see what it's going up by and keep writing it, but if we're trying to find the 50th or the 100th term, it's not a very efficient way of us doing that. So we're going to actually have a look at how we can use the nth term to find the answer to this. So first of all, we're going to actually find the nth term of this sequence. So to start with, we note that it goes up in threes. So the start of our nth term is going to be 3n, which means it's related to the 3 times table. And obviously using our little trick, we can go backwards. So take away 3, and that gives us positive 1 here. So it's 3n plus 1. Now thinking about what that means, and I've mentioned it in the previous video, and that means the 3 times table but with 1 added on. Now if we want to find the 20th term in the sequence, all we actually really have to do is sub 20 into this expression here. So n is going to become 20, or 3 times 20, so obviously the 20th term in the 3 times table is 3 times 20. So if we do 3 times 20, so I'm going to sub that in, 3 lots of 20, but then we just need to add 1 to that. So 3 lots of 20 is 60, and add 1 to that gives us 61. And that's how we can find numbers in a sequence quite quickly there. Okay, so find the nth term, sub the number in, and then obviously just write down what that number in the sequence is. But let's have a look at another one. Okay, so find the 50th term in the sequence. So again, let's find the nth term. So it goes up in 6's, so that's going to be 6n. And then we need to just go backwards, applying that little trick, so minus 6, and we get minus 4. So our nth term is 6n minus 4. Now again, we're trying to find the 50th term, so we're just going to sub 50 in place of the n, and we get 6 lots of 50, 6 lots of 50, take away 4. 6 times 50 is 300, and 300 take away 4 leaves us with 296 as our 50th term in the sequence. Okay, so this question says, is the number 49 in this sequence, and explain your reasoning. And this is slightly different because if you actually have a look at the sequence here, it goes 2, 7, 12, 17, 22. So actually all the numbers here end in 2s and 7s, and that's going to continue no matter how far we go there. So actually we could say straight away, well no, actually it's not in the sequence because 49 ends in a 9, and all the numbers in this sequence are going to end in a 7 or a 2. But let's actually look at proving it using a bit of algebra, even though we know it's already not going to be in there. So let's have a look. It goes up in 5s. There we go. So we know it's 5n. And if we go back 5, we get negative 3. So 5n minus 3. Now, taking the same approach, if we set this equal to 49, so does it ever equal 49? We should see here that something different is going to happen. So add the 3 to reverse that, take away 3. And that gives us 5n equals 52. Now, at this point here, if we put divide by 5, 52 divided by 5 is not a whole number, and actually it comes out as 10 and 2/5. There you go, 10 and 2/5. Or if you're doing this on your calculator, you could say that's 10.4. Okay, so as it comes out as not a whole number, it doesn't come out as an integer, 10.4, we would say no. Okay. Okay, it's the 10.4th term, or it's in between the 10 and the 11th term there, so it's not a term in the sequence. 49 is definitely not going to be in the sequence. Now these are solved in a very similar way to solving equations, okay? But obviously it's not an equation, it's an inequality. It's got our inequality symbol rather than our equal to symbol. So we're going to have a look at actually finding a range of answers here rather than just one single solution. So when we've got a sort of an equation that says 3x minus 5 equals 7, we're finding the exact solution that actually gives us this value. Now this inequality in this question, this is going to run throughout the video, says 3x minus 5 is less than 7. So what we're actually doing is we're finding what values of x would obviously give us answers less than 7. And that's what we're actually finding here when we use this inequality symbol. But as I said, we're going to treat it in the same way as solving equations. Obviously, if you want to get yourselves clued up on solving equations, I'll try and link the video in the description for that, for solving linear equations when we've got an x on one side or on both sides. But we're going to do exactly the same process. So I'm going to assume that we have a good knowledge of solving equations before actually approaching this. So I'm not going to talk about all the ins and outs of how we solve equations, but I'm just going to show you that we're going to solve this in the same way. Now we'll come to actually drawing it on the number line in SX. So before we get there, we need to actually solve this. So we've got a minus 5 on the left. Now obviously we want to isolate that x there. So I'm going to get rid of this minus 5 to start with. So if we add 5 to both sides, let's have a look what we get there. We get 3x, and that's going to be less than 7 add 5 is 12. So 3x has got to be less than 12. Now we can divide both sides by 3, obviously, because we want to know what 1x is less than, not what 3x is less than. So when we divide both sides by 3, we get x is less than 4, and that is our solution to this inequality here. X has got to be less than 4. Thinking about the logic behind this, look, if you actually put 4 into this equation up here, we would get 3 times 4, this inequality, sorry, I shouldn't say the word equation there. We get 3 times 4, which is 12, take away 5, and that would equal 7. Now obviously we want to know what's going to be less than 7, so what we found here is that as long as we put a number in less than 4, it's going to give us an answer there that's less than 7, and that's what we're looking for, which values of x are going to be less than 7. So all we actually have to do now to represent this on a number line is we stick our circle above that number, so above the 4 just here we'll stick a circle, and it's less than 4, so I'm just going to point it to the left, and it doesn't really matter how far I go, I'm just going to point an arrow saying it's got to be all these numbers here less than 4. Now obviously this circle here that I've drawn above the 4, let's do this in a different colour. This circle here can be open, and what I mean by open, just like I've drawn it there, it's empty in the middle, or it can be coloured in the middle. Now there's a little way of remembering whether it's coloured in or not. The other inequality symbol is we could have had this little equal to symbol on it as well. Now that little equal to symbol there has, and this is the way I like to remember it, it's got a little bit more ink on it in terms of when we draw it there's more ink. Now if there's more ink on the inequality symbol, there's more ink in the circle. So if it did have that little line underneath it, we would have a coloured in circle instead. There we go. But as this doesn't have the extra ink on the inequality, we're not going to put the extra ink there within the actual circle above the number. So we're going to leave it as an open circle, but I'm going to use that logic throughout these questions here. When we've got the extra ink on the inequality, we put the extra ink on the circle. That's just a nice little way of remembering it for you. Okay, so this question says write down the integer values of x that satisfy this inequality and show this on the number line as well. So when we're looking at these integer values that satisfy an inequality, we're looking at what numbers fall between these values here within this inequality, and that inequality just means the numbers between -2 and 3. But if you have a look, this inequality here says it can be equal to that one on the left, but it cannot be equal to this one here on the right, the 3 there. So we've just got to watch out for that, because it can be equal to the -2. So if I was to draw out all the numbers, look, it'd be -2, -1, 0, 1, 2 and 3 between that inequality, but it cannot be equal to the 3, so we just want to get rid of that 3 and just cross that out. Okay, so you can always not write that, so if I just erase that 3 we can get rid of it, but you can always just write them all out and then cross off the ones that you don't need, if that just helps you just to visualize that a little bit. So they are the integer values, obviously integer meaning whole number, so that they are the numbers that fall between that inequality. Okay, so now we need to draw this on the number line. So all I'm going to do is I'm going to pick those numbers there in the inequality. We've got the -2 and we've got the 3. There we go. And it says it can be equal to the -2, so it's got more ink on the -2, so I'm just going to colour that one in. But it can't be equal to the 3, so I'm not going to put the any colour inside that circle there. And all I'm going to do now is just connect them together, just to say that there we go, the number is limited between those two. So it can be equal to -2, but it can't be equal to 3. It can be anything as close as you can possibly think of to 3, but it can't actually be 3 itself. It could be 2.999 and so on, but it can't actually be 3. So there we go, that's how we would draw that inequality there on a number line. Right, okay, so obviously we've been drawing these inequalities, but actually we could be asked to actually write down the inequality that's displayed on the number line. And obviously we've looked at quite a few different ones here. We've had singular circles with arrows pointing either way, and obviously we've had these joint ones where we've got a circle on either side. So this particular one here says write down the inequality shown on the number line. Now we know what this looks like. And obviously there is an x over here, so we'll have x in the middle still, but it could be a different letter there. I've just used x for these questions, so we know what it's going to look like. We're going to have an x in the middle, an arrow pointing to the left on either side, and one of them has the equal to symbol. Look, this one has the more ink in it, so that's also going to have an equal to symbol, and then the numbers underneath those, we've got 4 and -3, so -3 on the left and 4 on the right, and there we go, there's our inequality drawn. Okay, obviously you could have some slightly different ones here. I don't really like that highlighter there. Let's make that a bit bigger. There we go. All right, there we go. So what we could actually also have is a number line where we've just got a singular circle. So let's just imagine, look, if I had one above the 1 maybe pointing to the left, that would just be x is less than 1. We could even have one pointing to the right. I could even have it, look, let's do it over here on the 5 pointing to the right, and that would be x is greater than 5, or it could even be coloured in, look, and that'd be x is greater than or equal to 5. So all these different kinds of inequalities that we can have drawn on the number line and actually just write those inequalities ourselves. But obviously we've already looked at actually doing them. We're just now doing it in reverse and writing what those inequalities are. But don't remember, all you have to do is write it exactly how you speak it. X is less than 1, like this one, so x less than equal to, less than symbol, sorry, and then a 1, or like the one on the right here, x is greater than or equal to 5, so we just write it as we speak it. Okay, so there's just a couple of ideas of what you could also have, but obviously this question we looked at here was one of these dual inequalities where there's a circle on both sides. So obviously just remember those arrows are both there pointing to the left on this one there, just to show that it's between those two numbers. Okay, so our first question, we are starting with a quadratic. Now we know that a graph is a quadratic if it has a little squared in it. So this particular graph has x squared, and this is quite a nice one, it's just x squared take away 4. Now normally you're asked to complete a table and then also draw the graph. Now my main priority for this video is going to be on actually getting these tables completed. I like to hope that we can all draw these graphs once we've got the coordinates. So I'm not going to stress too much about the actual drawing here. In fact, the actual graphs that I've got on the screen are quite small and mine aren't going to be perfect, but I'm just going to give you the general idea of how to go about drawing all these graphs here. So for this one here, we've got y is equal to x squared take away 4. Now that obviously means just to find the y coordinate, we square the x coordinate and then take away 4. So it's hopefully quite nice and simple. We're going to have a look at a trickier one after this where you just got to be careful with how you actually go about doing this. So it says for all the values of x from -3 to 3. Now if it doesn't give you that information, you can find them along the x-axis here. If you have a look, the x values stretch along from -3 along to 3 there. So that's where we get them if it doesn't tell us, okay, or if we're not given a table. But for all of these, I am going to give you a table. Now obviously we are starting with this one on the left, so we've got -3 there, and we need to sub that into our equation. So to find y, I'm just going to write the working out. We would do x squared, so -3 squared, and we've got to be very careful when we're writing -3 squared, because particularly if this is a calculator question, if you type that into the calculator, you are going to get the answer -9, because what the calculator does is it squares the 3 and then puts the minus with it. It doesn't actually do -3 squared. So a really important little thing that you need to remember throughout this is that we're just going to put all our numbers in brackets like that. Okay, so we're going to write -3 in brackets squared, and then we're going to take away 4. Of course, if this is non-calculator, we can work that out anyway, because we can do -3 squared, which is +9. So we've got 9 take away 4. And that gives us the answer 5. So we know that that number there is going to be 5. We can then move on to the 0. And again, I'm not going to write all the working out down for every single one here, but we would just do 0 squared. Again, we'll put the 0 in brackets, although it doesn't matter if the number's not negative, and then take away 4. And 0 squared take away 4 is -4. So we can just put -4 straight in there, and the rest, and this next one here I'm going to do without writing the working out down. We've got 1 squared, which is 1, take away 4, which is -3. Now it's not that easy to spot, but obviously when it comes to straight line equations, there's always quite a nice pattern in the table. When it comes to quadratics, there's not the nicest of patterns, okay, and the others aren't going to follow a pattern, but there is actually a bit of a pattern in a quadratic. If you have a look, we've got -4 in the middle, and either side of that we've got -3, either side of that we've got 0, and either side of them we've got 5. So there is a bit of a pattern, although I certainly wouldn't rely on these because they don't stay there throughout all of the graphs, and sometimes it's very difficult to spot some of these patterns. But just thinking about the fact that there is a bit of a pattern when we're looking at these. So let's have a look then. Actually plotting this on the graph, now we've got an x and a y coordinate there. That little bit there, x is -3, y is 5, so that's the coordinate -3, 5. Now I'm going to plot these quite quickly. -3, 5 is somewhere up here. I'm not going to be able to do them perfectly on the screen here. Then we've got -2, 0. We've got -1 to -3, obviously getting your x and y coordinates the right way around here. 0 to -4. And then it repeats the pattern going up the other side there. So we've got 1 and -3, we've got 2 and 0, and we've got 3 and 5, which is somewhere up there. Right, so in terms of actually drawing the graph here, we've plotted the points. We now need to get a nice smooth curve that goes through all of the points. So not with a ruler, a nice smooth curve, and it has to go through every single point. So I doubt I'm going to get this perfect. I'm going to give it my best shot. I'm just going to do a nice smooth curve. Ooh, no little kinks in it. I actually can't see them as I'm doing them. There we go. So I've done it as best as I can, but you want to get yours nice and smooth. Okay, so make sure you do it with a pencil. Rub it out if you have any kinks like I've got down the bottom there, but then you can go back and have a go and actually rub it out and just make sure you get a nice smooth curve there. Right, so that's what a quadratic graph looks like. We're going to have a look at a slightly harder one. Before we move on there are a couple of things to know about this quadratic graph and a couple of the points that are important. We're not going to look at them specifically in this video, but there are 2 places which are, well, technically 3, but there are 2 things that are quite important with a quadratic graph. One of them is this point right here at the bottom, where it sort of stops going down and starts going up. That can be called a couple of different things. It's got a specific coordinate there. It's 0, -4. It can be called the turning point. There we go. or it could be called the minimum point or the maximum point if it's sloping another way. So the minimum point or turning point. There we go, the turning or the minimum point, that's a very key place on a quadratic graph. And there's also two other points here, which is where it crosses the x-axis. So we've got these 2 points there, which is -2 and 2. Let's just write that in there, -2 and 2. And these have a special name as well. They've got two names again. They can be called the roots. There we go. Or they can be called the solutions. There we go. Roots or solutions. So we're not going to focus on those points in this particular video, but obviously just a couple of extra little bits to be thinking about there. The roots and the solutions where it crosses through the x-axis, and the turning or minimum point down the bottom. Obviously just adding a little bit of context to the language there. The turning or the minimum point seems like quite an obvious place, so you would just give that as a coordinate 0, 4. But then the roots, okay, doesn't always necessarily have a bit of a logic there, but I do like to think of this x-axis as being ground level. And when you think about plants and things like that, where they meet the ground is where the root starts. So I do like to think of these sort of things as like the little roots there, and that's sort of where the word comes from. But you've also got the word solutions, so there's not really any context there, but it's just where it meets the x-axis there. Right, okay, so I'm only going to do one of these cubic graphs because the process is pretty much the same. We just need to think about what they look like. Now, a standard x cubed graph, if I try and draw it as best as I can, has this sort of shape. Okay, not perfect there with the numbers, but it has this sort of shape. It crosses through the origin and it has this sort of wiggly line shape, and we'll look at why it's made. But that one there is what x cubed looks like. It just crosses through the axes just on 0, and that is going to come up later in the video when we're looking at just these x cubed graphs. But we're going to have a look at obviously what they look like when we've got a little bit more than just x cubed within there. So obviously this question has x cubed minus 3x plus 1, and all we're going to do is put the values into the equation just like we have done before. So for -2 that we're going to put in, we've got -2 that's getting cubed. Then we've got take away 3 lots of that -2, and then we're going to add 1. And when you cube a negative, it does stay negative, so it's just like doing 2 cubed, but it's going to be -8 this time. 2 times 2 times 2, but it's -2 times -2, which makes +4. Times it by another -2 makes -8. Then we've got the -3 times the -2, got to be careful there, so that's going to make +6, because we've got a negative times a negative, and then add the 1. So -8 plus 6 is -2, add the 1 is -1. So there we are, there's our first coordinate, -1. On to our next one. We've got 0 to put in, that's quite nice. 0 cubed is 0, take away 3 lots of 0 is still 0, add the 1, gives us 1, that's a nice quick one. And then for the last one there, we've got 1 cubed, take away 3 lots of 1, so 1 cubed is 1, take away 3 is -2, and then add the 1 is -1. Okay, so we need to go about actually plotting these points on, and there's not really much of a pattern there. You might be able to spot something, but let's just get it on and see what it looks like. So -2, -1 is here, -1, 3 is here, 0, 1 is here, 1 to -1 is, let's have a look, 1 minus 1 is there, and then 2 to 3 is here. There we go. So that looks very bizarre when you're actually plotting this on, but remember it has this sort of wiggly sort of curve that I showed you before, but this one is just a little bit more stretched out. Let's have a look. We've got coming up there, down to here, and up to there. There we go. And that is our sort of cubic graph and what it actually looks like. Obviously these lines would actually continue here. Okay, and we'd sort of get the same sort of shape that I've got there, but just a bit more of a kink in the middle there. Okay, so obviously don't extend past those points, but that's what our cubic graph is going to look like. Okay, so what we do find is when we don't just have x cubed, it has more points where it crosses through the x-axis. So obviously we've got 1 here, 1 there, and 1 there, so we can have a potential of obviously up to 3 points going through there as well. Okay, so a lot of these cubic graphs do have this slightly bigger wiggle that sort of crosses through the x-axis a few more times, but if it doesn't have any sort of additional elements going on with the x cubed, it does just cross through at the origin there. Okay, but that is our cubic graph. Okay, so a reciprocal graph. There we go. So we've got our line equation here. It's y equals 4 over x. So this is what forms a reciprocal graph. This is when you've got a number getting divided by the x there, and it forms a particularly different looking graph as well. So this is called reciprocal, and let's just have a go at filling these numbers in the tables and seeing what we get. Now I actually think these are probably one of the easiest ones to plot, but they do normally tend to just throw people a little bit, particularly if they haven't seen one. So let's just have a think about what this actually makes here. So we've got 4 divided by x, so we've got 4 divided by 0.5, and there we go. Obviously if you don't have a calculator here, there's a couple of little tricks you can do to figure that out, but dividing by a half just doubles the number. If you think about it logically, what a half fits into 1 twice, it doubles the 1, it makes the 1 2. So if we do 4 divided by a half, we get 8. And again, you can check that on the calculator, but it just doubles the number there. The next one along, we've got 4 divided by 4 here. And 4 divided by 4 is 1. Here we've got 4 divided by 5. Not very nice. 4 divided by 5 is 4/5. 1/5 is 0.2, so that's 0.8. It is quite most likely you would have this using a calculator, but obviously just quite a nice one if we didn't have a calculator, and thinking about how we'd approach that. And the last one here, we've got 4 over 8. 4 over 8 simplifies as a fraction. It's 1/2. So writing that as a decimal, 0.5. There we go. So we've got some slightly different values here. You'll see it starts off at 8 and it gets smaller and smaller and smaller as we sort of increase the number there. And obviously think about the logic behind why that happens. We've got 4 dividing by a number. If we divide that by a small number like 0.5, we get a large answer. Divide it by a big number, obviously, or just an increasing number, that's going to make our answer smaller and smaller. So if we actually go about plotting this, we've got 0.5 down the bottom all the way up to 8. That is there. We've got 1 that goes to 4. We've got 2 that goes to 2. 3 goes to, we don't have 3, so we can't do that. 4 to 1. 5 we've got 0.8. I'm trying to do this as best as I can. 4 little squares up. And then we've got 8, which is 0.5. And that's there. Right, so joining this up, what we get is, and I'll try and do this as best as I can, a nice smooth curve again. We just get this sort of, there we go. There we are. And we get that is what a reciprocal graph looks like. Now what we don't have is a full 4-quadrant graph here, but if we did, our bit that we've drawn would go in here. And if we actually looked at the negative element of this graph, so subbing in some of the negatives, like if you imagine we put minus 0.5 in, minus 0.5 would give us minus 8, which would be down here, and the rest of the graph would then form that same pattern going this way. There we go. There we are. So obviously it's not asked us to draw that negative part for this particular graph here, and it very rarely actually does, because it's actually quite complicated obviously to have a 4-quadrant graph and draw all of those elements. But there's something a bit strange that happens in a reciprocal graph. Obviously we've got 2 different lines there. We've got the positive element over here, which we've drawn on our graph, and you can also have the negative element over here, but they don't actually join up. And if you think about the logic there, that's because if we put this point here in the origin, we would end up with 4 divided by 0, and dividing by 0 is obviously an impossibility in maths. We can't actually divide by 0. It doesn't make any sense, so we can't actually do that. We can't actually get a value for 0, and because of that it sort of jumps away from the origin and actually never touches the axes there. You think no matter what number we put in, we're never going to get a value of 0. We can keep making 0 smaller and smaller and smaller, but we'll just get a bigger answer for y. We can keep making x larger and larger, but again we'll just get a smaller value of y. It will never actually hit 0. So these sorts of graphs here never actually touch the axes, but there we go. That's what sort of defines just a little bit to do with this graph here, so you understand why it looks the way it looks. Right, so the first one, we've got an x squared graph, so that is matching up to our graph A. Okay, we've got that U shape, that parabola it's called, it's our quadratic graph there. The next one we've got the x cubed. Now we've got 2 possibilities for the x cubed. We've got this wiggly one here, and we've also got this wiggly one here. So if you remember what I said about that, if we've just got the x cubed, it just crosses through the x-axis at the origin. Obviously this one over here on B crosses through at 1, 2, 3 points, and this one just crosses through on the 1 point there. So our x cubed graph from that equation is f. And for our last one, we've got our reciprocal graph. Okay, we've got 2 possibilities. We've got C up here and we've got D down here. Now we've not, obviously that is very similar to the ones we were looking at, and the ones we were looking at look like this. To actually get that one C there, we'd have to have a negative x on the bottom and start sort of changing the equation up a little bit. Okay, but that's when we've got a positive value of x there, it's our graph D. Okay, so obviously they look very similar to the ones that we've drawn. We drew a graph that was basically x squared with the A. With our first one we did x squared minus 4. We very quickly looked at the actual x cubed graph when I mentioned what that looked like for F, and then our last one there for D. We literally just looked at that one there, and I actually drew that little picture when we were looking at reciprocal graphs. So this first one says, on the grid, draw the graph of y equals 2x plus 1. Now there's lots of ways of doing this, but essentially it's just about understanding what this actual line equation means here. So we know, hopefully, that all line equations need to be in this form, y equals mx plus c. Okay, so y equals mx plus c. Again, in this line equation, m represents the gradient, which in our line equation here is the number 2, so we have a gradient of 2, and c at the end there represents the y-intercept, which for us here is positive 1, so we've got a y-intercept of positive 1. Now in terms of what that means the graph's going to look like, we know it's going to cross through positive 1 on the y-intercept, which is right here. There we go, I'll try and mark that on, there we go. So we know the line's going to go through this point. And all we have to do is figure out where all the rest of the coordinates are. Now in terms of y equals 2x plus 1, remember x and y relate to the x and y coordinates. So all that this equation actually means is to find the y coordinate, you do 2 times the x coordinate and add 1, or double the x coordinate and add 1. So all we need to do is actually pick some x coordinates. Now if you have a look on the graph, you can see there's lots of x coordinates here. We've got -1, 0, 1, 2, 3 and 4 at the end there. Okay, so all we have to actually do is pick them, double them and add 1, and that'll tell us where the corresponding y coordinate is. And we can do that using a little table. You don't have to use a table, but it just tidy it up a little bit if we just make a little table here. Sometimes you'll be given the table, but it's quite unlikely that you'll be given it. So we've got some x coordinates and we've got some y coordinates we need to find. Now for x, we've got starting at -1, and then it goes 0, and then we've got up to 4, so 1, 2, 3, 4. So if we start with -1, this one here, we need to double that and add 1. I'm going to just sub that into my little equation up there. So y equals 2x plus 1. So it's 2 lots of -1, 2 times -1, and then add 1. And if we double -1, we get -2. Add 1 to that, gives us -1. So our first y coordinate there is -1 as well. So -1, -1. And we can plot that if we want straight away. There it is, -1, -1. Moving on to the next one. What do we have for this next one? We have the x coordinate of 0. So if we just, without doing all the working out for all of these, let's double 0 is 0, and add 1 is 1. So 2 times 0 is 0, add 1 is 1. And if we carry on doing this for the next one, so when x is 1, double 1 is 2, and then add 1 is 3. So double 1 is 2, add 1 is 3. And you can start to see there's a little bit of a pattern emerging. Okay, between all of these points, if you have a look from -1 to 1, that is adding 2. From 1 to 3, that's also adding 2. So actually all we need to actually do is keep adding 2. So add 2 to 3 is 5, add 2 again is 7, and add 2 again is 9. And then we can go ahead and plot as many of these as we can. Obviously we can't do them all here because the graph's not big enough. But for the next one, let's have a look. 1 to 3 is there, and 2 and 5 is there. Okay, so they're all the points we can plot. We could actually only plot it up to this point here. But once we've done that, all we need to do is grab a pencil, grab a ruler, and join it up nice and straight all the way through the graph, unless it states otherwise. So with your ruler, nice straight line going all the way through and extending it up to the edge of the graph there. There you go, and that is your line. And it's always good practice just to label it. You don't have to, okay, but you could just label that as the line y equals 2x plus 1. It just helps if there are multiple graphs or multiple lines on the graph, but you don't have to label it unless you're asked to. Okay, but there you go, y equals 2x plus 1. Okay, so in this question we are given a line already drawn on a graph, and it says write down the equation of the line. Now we know already that what the equation of a line is going to look like. It's in this format, y equals mx plus c. Again, that's c being the y-intercept. Now we can see the y-intercept on the graph. It's over here, 5. So for starters, I can actually just draw that straight in. We can say c equals 5, and we can just put that in our line equation. So y equals mx plus 5. All we need to figure out is what the gradient is. Now if we have a look at this question, we've got to find some coordinates that we can actually see. So here's another coordinate that's on the line, 1, 3. Now if I want to find the gradient between these 2 points, all I have to do is draw a little right angled triangle in, so I can go across or down from this red point. But if I go across and then down, I'm just going to say how big the movement is there. So that's a movement of 1 there, and then that's going down 2, so I'm going to say that that's -2. Now the equation to get the gradient, there's 2 different ways that you can look at it. You can have a look at it, and it's just use this little triangle. It means the change in, so it's the change in the y coordinate over the change in the x coordinate, and it's sometimes referred to as rise over run. Okay, so you might know one of these 2, but change in y over change in x, or rise over run. Now in this case, look, the change in the y coordinate is this movement here going down, it's -2, so that'll be on the top of my little fraction here, -2, and the run, or the change in x, is on the bottom there, is the 1 going across, so it's -2 over 1, and -2 divided by 1 is -2. Okay, so my gradient here is -2. So it's obviously sloping downwards, which is why it's got a negative gradient, but that's what our gradient actually is for this question here. So all I've got to do is put -2 in place of m, and we get y equals -2x plus 5. Obviously, thinking about that last question that we looked at, you could actually write that as 5 minus 2x, but you can write it in either way, it's absolutely fine to do so. Just a little side note, you can actually do these triangles as big as you want. If I picked some different coordinates, let's have a look, that one there and this one here for example, and if I was to go down instead and make a big triangle like this, let's have a look, my run there is 4, and my rise goes from 7 down to -1, which is a movement of -8. And if I did rise over run for this one, or the change in y over change in x, it would be -8 over 4, and -8 divided by 4 is -2. So you can do this however you like, okay, because it's a straight line, it doesn't actually matter where you do the gradient from, it's just you just need to draw it in, just read those numbers very, very carefully so you can get the correct gradient there. But here's the first one, it says here's a square base pyramid and it wants us to draw an accurate front elevation from the direction of the arrow. So there are 3 types of elevations we look at, one's from the front, one's from the side, and to be honest, if we twist it round, either could be the front and the side, it just depends on how the diagram labels it. So here it says the front is going that way, and it says the little arrow just down here, so facing that way, the front of the pyramid. Okay, and we could also have a look at the plan, which is like a bird's eye view looking at it from above. Again, and what we're going to draw is the 2D image of what we would see. Now obviously in real life we have a little bit of depth perception, so we can see if like elements are a little bit further away or whether they're closer to us, but in terms of taking an actual photograph of it from the front, you can't really tell the actual depth or how far back it goes or how far forward it comes at the base and stuff like that. So we're going to think about what we can actually see here from the front, and what we can actually see is a triangular face. Okay, and if we imagine that we were standing over here, there we go, this is us standing facing the pyramid, we would actually just see this triangular face as long as we were smack bang in the centre there and we couldn't see any of the other edges. I'll try and colour it in as best as I can. There we go. So that's what we're going to draw there. Now obviously we will see the 6 centimetres along the bottom, so I can draw the base in. That's going to be 1, 2, 3, 4, 5, 6. And I just need to get the remainder of the triangle correct there. Now, we wouldn't see the 5 over here. We wouldn't see the height as being 5 because that's slanted. The actual height that's given to us in this particular question is the 4 centimetres, and that's how high the pyramid is. Now, that 4 centimetres there on a square base pyramid is going right down to the centre of the square, so it's smack bang in the middle. So in the middle of the base is here. So we want to find where that tip of the pyramid is 4 centimetres above the centre of the base there. So if I go up 4 centimetres, 1, 2, 3, 4, that gets me to here. Okay, so we're having a look at that as being the centre of our pyramid. Let's get rid of those, and then all we need to do is just connect that up. There we go, and that's what we would see, and that's our triangular face from the front there. Again, if it had have asked from the side, you can imagine, if it did imagine from this side, it would look exactly the same. It's the same triangle there with a height of 4 and a base of 6, as it's a square base pyramid. But there we are, that is how we go about drawing one of these front elevations here. Okay, we could also be asked to draw the plan, and that would just be a square. Okay, if we were to draw a square, we'd have a side length of 6, and obviously you might want to draw those lines in as well. In fact, drawing the plan wouldn't be very nice. I won't draw it accurately, but it'd be a square like this, and we'd see these sort of 4 lines of the pyramid crossing over. Okay, so obviously it doesn't ask us to draw that, but just thinking about another question it could ask us to draw here, and that's what it'd look like, obviously making sure the side length is 6 centimetres there. But there we go, we didn't need to do that, we just need to get the front elevation. So that's our first question. Let's have a look at our next one. Right, okay, so here we go. We've got a prism here with a trapezium as its face, okay, as its front face anyway. And it says here the diagram shows a prism with a cross-section in the shape of a trapezium. On the centimetre grid, draw the front elevation and the side elevation of the prism and use a scale of 2 centimetres to 1 metre. So if you have a look at obviously the dimensions here, we've got metres in terms of our dimensions. Okay, and we need to convert those back into centimetres in order to draw them on our grid. Now, first of all, it says the front and it says the side. So if we have a look at the front to start with, and the front elevation, let's get rid of all that. The front elevation is down here, okay, looking at it from here. So if we're looking at it from the front there, again, imagine that we're standing there. We don't have any sort of depth perception. We're standing right perfectly in front of it. We are just going to see this flat trapezium face here. There we go, that yellow one that I'm colouring in. So I just need to be able to draw that shape there in 2D on the grid. Now obviously it says 2 centimetres is 1 metre. So we've got a height of 2 metres there, so that's going to be 4 centimetres. And again, you can label that on here. Every 1 metre is 2 centimetres, that'll be 4 centimetres. So I'm going to draw this on the left. 1, 2, 3, 4. There we go, as it's a centimetre grid, each square is 1 centimetre. Then we've got 4 centimetres along the bottom as well, because that is also 2 metres there. So I'll go another 4 across. There we go. We've got half a metre there, so half a metre, it's 2 centimetres is 1 metre, so that's just going to be 1 centimetre. So we have 1 centimetre going up, there's that bit, and then we're just going to connect them up, there we go, and that is our front elevation. Let's just label that the front. There we go. Now we also need to draw the side elevation. Now thinking about the logic here as well, obviously the side elevation's over here, so let's do this in a different colour. I'm now going to be standing over here looking at this rectangle, and obviously I've got the arm sticking out of his head there, there we go, there we are. Right, okay, so we're standing having a look at this. I'm going to highlight this in a different colour. So now when we're standing there, we're going to see this rectangle. Okay, we're definitely going to see this rectangle, and we're also going to see over and above that this slant here, okay. Now we're not going to see it as a slanted shape, we're just going to see it as part of the rectangle. Now the height of the shape is not going to change there just because it's got a slant. So we already know, just thinking about the logics here, that the height of the shape can only be as high as from the front, okay? So just obviously match the heights there without even doing the measurement there. Okay, we know it's 2 metres high, so that's 4 centimetres again. And it's not going to be any higher no matter which side we go, okay? So it's going to be the same height. And we just need to get the width, okay? So 1 metre there, so that's going to be 2 centimetres along. So we know it's going to be 2 centimetres along, and it's just going to be one big rectangle, so we can join all that up, and that's basically what it's going to look like, okay? But there is one other element that we need to add here, and that's the fact that there is a change in sort of slope there, shown by this line, and we're going to show that little line there. So that's half a metre up, again that's 1 centimetre up, and that's going to be a little line here, and again if you have a look, it's in line with that little kink there in the front elevation. So there we go, that's our side elevation. There we are. And that's that done, both of them being the same height. Obviously we've got to think about logic here. The shape isn't going to be taller or shorter from a different angle, it's just that we're going to see it in a slightly different way. So obviously this particular face, and if I get rid of some of that green face there is sort of the strangest, because this one here, look, it looks a lot smaller than on the diagram, but we obviously as a 2D shape don't have any perception of the depth of that and how far back it goes. We just see it as an actual rectangle there. Okay, but there we go. That is our front and side elevation for this one. Bit of a strange one. You have to think about the scale as well there, so that made it a little bit nastier as well. But obviously just try and think about a bit of logic there in terms of matching them up with the front elevation, which was a lot easier to draw, but just making sure it was the same height and it had that same little notch there at the half a metre up point. Now this bit's really important. It says you must give reasons for your answer. Now some of the time I'm going to write down my reasons, okay? When you are doing these questions you always need to write the reasons down, but I'm going to try and minimise the amount of writing that I do just to save a little bit of time as we're going through this, okay? And I'll just speak about them instead. But we will write them down initially and start thinking about maybe a little shortcut that I can write down just so that you know when and where we're going to write down those reasons. So having a look at this question then, we've got these parallel lines, okay, and the parallel lines are indicated via these little arrows here. Now when you have a line that is going through those parallel lines, so from B down to E, this one here, there are lots of rules and angle rules around about these angles. I'm going to extend that a little bit further because it does go all the way through there. Okay, so obviously in this question we've been given the angle of 47 down there, and it wants us to get all the way up to that angle of x. And to be honest, there's probably about 5 or 6 different ways of actually getting there, but when it comes to a question like this, you have to almost ignore what we're actually looking for, and we're just going to find everything. Okay, we're going to have a look at working out every single angle around all these points here. Now when it comes to obviously the parallel line rules, there's a few that we need to know, okay, and that's how we're going to jump from one line up to the other. And what I mean by that is that's how we're going to get from down here on this line and we're going to jump up to this line here. Okay, so those little rules that we're going to have a look at. The first of them, and there's two different ways of writing this, but the first of them, and you hopefully recognize this, it makes this Z shape, okay, and those are called alternate angles. Okay, so if we make this little Z shape here, okay, that's going to be an alternate angle, and our reason there is that alternate angles are equal. And there we go, alternate angles are equal. There we are. And throughout this video, obviously, if we ever use an alternate angle, that's the exact reason that we have to give. We have to say that alternate angles are equal. That is a reason, okay? We don't just state that it's an alternate angle. We actually give that as a reason and say exactly what that means and in terms of how we get in there. So that angle there hooks particular angles in it, hooks these two either side, and those two angles are equal. But of course, you could have that angle going along the other side as well. Okay, we could make what kind of looks like a backwards Z. I could make a little Z going this way as well. And that hooks in this angle here, X, and this angle down here. And as you might be able to already see, that's going to give us part way or a little bit of a hint towards how we're going to get to that final answer there. But okay, let's get rid of that, because there are other angles as well that we might have throughout these questions. And one of them is when it creates this F shape. Okay, and these angles here, I'm going to draw this out. So a little F shape, and they are called, and it hooks in this one and this one underneath the F that time, and they're called corresponding angles. And the reason again is that corresponding angles are equal. Okay, there we are, corresponding angles are equal. Okay, that's another reason that we might have throughout this. So as you can see, if that's 47, this is also going to be 47 up here. Okay, but just thinking about different ways that we can get there. So that's two different rules, and you might have already spotted we could use either of those to actually get our final answer up there. But again, before we move on, there is one more angle rule that we might have to use throughout this video, and that is when it forms this little C shape here. And angles within that, again the ones that they hook in there, these ones here, they add up to 180, okay, and they are called co-interior angles. There we go, so I'm just going to draw this as a little C, and co-interior angles add up to 180. There we go, so co-interior angles equal 180 degrees, or add up to 180 degrees. Okay, so obviously those are the three angles that you need to make sure that you've got, or the three angle rules that you need to make sure that you've got written down throughout this video, because we're going to be using at least one of these in every single question throughout the video, so you need to know these pretty well and sort of recognize how to spot them. But essentially you are always looking for a line that jumps or moves from one parallel line to another, and in the case of this one on the screen here, it goes from B to E, and it does extend down to G, but that's our line that's going through the parallel lines there. Okay, so we're going to have a look at actually going about answering this. So we're going to see how we can actually get to an answer, but let's have a look and see which one of these angle rules we might be able to use. Now, there are lots of different ways of going about this, okay? In fact, we could go, and we'll talk about three different ways. Okay, so I'll start with one way. One way we could do is we could get this angle here, then say that that's 47. So not one of the rules that I've talked about, but when we get this little X shape going along here, two lines crossing over, it creates these two angles here. And this angle here is vertically opposite to the other angle there. So I would say that that angle there is 47, because vertically opposite angles are equal. There we are. And you don't just say opposite angles, you do say vertically opposite angles are equal. There we go. Are equal. Right, there we go. So vertically opposite angles are equal. That's my first reason there. And then I could move on to another angle, okay, and I could actually spot one of my parallel line rules. Now I could either from there get my Z shape, and that would give me this angle up here, and that would be alternate. Okay, I could say that that's 47, okay, because alternate angles are equal. There we go, alternate angles are equal. And then from there I could do angles on a straight line. Okay, again, let me just get rid of this Z shape. There we go, we've got angles on a straight line, so next to that X there, these two angles have to add up to 180. So I would simply do 180 and take away 47, so 180, take away 47, and that would give me 133. There we go, that'd be 133 degrees as my final answer. Okay, and showing that there, 180 minus the 47, and obviously just always showing you working out there. So my final reason, because it does say you must give reasons for your answer, I would say angles on a straight line equal 180. Now I'm not going to write that down again, I'm going to stop writing some of these down because it's going to make this video about twice as long if I have to keep stopping and writing them all down, so I will just speak them instead. But there we go, that's one way of getting there. There are other ways as well. I could have maybe not found this alternate angle. I could have then had a look at this as the co-interior angles. Look, I could do 47 with that one, makes that backward C shape, and those two angles have to add up to 180. So obviously I'd do 180 take 47 again, and that get me straight to the 133. But again, there are lots of different ways that I could get there. I could have even done angles on a straight line here. I could have done next to the 47 is 133 and got that one first, and then we could have done, I'll swap to the same colour as the picture over there, there we go, I could have done my F angle shape there, which is a corresponding angle, so I could have done corresponding angles are equal as well, and I could have done any little combination of those on different sides of the line, but essentially there you just got to find your way of getting there, okay, and make sure that you label and describe whatever reasons you are using, okay, that's what's important. In whatever way you do it, you need to obviously give the reasons for those. So the particular way that I did it, and I did it on the first one, I did vertically opposite angles are equal, then I did alternate angles are equal for this one, and then I did angles on a straight line equaling 180 for my final one there. But there we go, there's some of the rules. Obviously you need to just make sure that you've had a practice on some of those. Now this question says work out the bearing of B from A. Now there's a few things that we need to discuss when it comes to bearings. For starters, there's three really important rules. When it comes to bearings, we always measure from north. Okay, so I'm just going to write these down to the side with the first one. So we measure from north. So north is just going to be our starting point for all of our bearings, okay, and that's going to be absolutely crucial. Obviously we've got to have a place to start from, and north is obviously just quite an obvious one to go from when we're measuring a particular degree when it comes to directions and bearings. So that's our first rule. We've got to measure from north. The second one is the direction we measure in. We measure clockwise. Okay, so we always go clockwise. Okay, no particular reason why. It's just that we obviously have to pick one of them out, what clockwise or anti-clockwise. So it just seems obvious for us to go clockwise, really. And our third rule is that the bearing has to have 3 digits. Okay, so all bearings have got to have 3 digits. So that means something like 20 degrees. Okay, would be written as 020 degrees, okay? So obviously it doesn't apply to any numbers that are already 3 digits, like 120 degrees would always be 120 as it already has those 3 digits. But if any numbers don't have 3 digits and we're given a bearing like that, we will use 3 digits. So there are 3 really important rules. We're going to measure from north clockwise, and we're going to use 3 digits and apply that to any numbers that aren't already 3 digits, okay? So this question says work out the bearing of B from A, and the language is always quite nasty. You know, you've got to get your head around it just to start with. Once you've got your head around it, it's fine. But it says work out the bearing of B from A. So you just have to look at that second bit really. Look, we're going from A. So if we imagine we're a little person, we're standing at A, there we go. We want to know how to get to B basically. So what's the bearing of B from A? Okay, and we could have a look, we'll have a look at all the different types of language as we go through this. But if we're standing at A and we want to get to B, bearing in mind that we're going to be facing north, that means to get to B, the bearing is going to be all the way around clockwise to this line here, obviously B being down here at the bottom, so that line with the B at the end. So we've got to figure out all that direction going across now. This diagram's quite nice, look, because it's put this little dotted line going downwards just to sort of show us this obviously straight line going south. Now that may or may not be there, okay, but obviously this one is. So all we've got to have a look at really is how many degrees that is now. Facing north, to get to south, look, that is a full turn. So that's a full 180 degrees. So it'd be 180 degrees for us to turn just to be facing south. Then there's this additional 40 degrees. So all we need to do is add those two together. So we have 180, add 40, and that will give us a combined total there for our bearing of, let's have a look, 220. There we go. So our combined bearing there for those two little parts to get to B from A is 220 degrees. Okay, so this question says there's two regular pentagons and an equilateral triangle, okay, and it says calculate the size of angle DEH, which is this angle here. Let's stick a little X in there. and you must show all your working. And this is really important on this type of question. You must show all your working, and you've got to show how you go about getting the interior angles there. So obviously we've just done a pentagon, so we know it's 108, but just writing 108 in there wouldn't be showing my working. So whichever method you decide to do, I'd have to do show my work in there. So I'd do 5 minus 2, which equals 3. 3 times 180, which gets me 540, and you might have to do some written methods here, and then divide that by 5. So 540 over 5 gives me the angle of 108, and that is me showing my working there, how I get the angle inside the pentagon. So we can put that in, 108, and I can put in 108 here. Now the reason I've gone for this corner here is because they're all slotted together. We're looking at angles around a point here, and we know the total of all these angles is 360 degrees, so 360 degrees around a point. The final angle here that we have to find is the one inside the equilateral triangle. Now, for an equilateral triangle and a square, we don't actually have to show our working for that. It's presumed that we should know those. And inside an equilateral triangle, the angle's 60. There we go. So if these have all got to add up to 360, all we've got to do is add these all up. So 108 plus 108 plus 60. And that gets us 672, so 276 degrees, and we just need to take that away from our 360 up there. So take that away, take away 276, and that leaves us with 60, 70, 84 degrees. There we go. So our missing angle there is 84 degrees. Okay, showing all our working in stages as we go. So first things first, we worked out the pentagon, then we added up all our angles, and then we took it away from 360 to find our missing angle there. So nothing too horrible in these questions. Again, you've just got to make sure with this type of question you label everything all over the diagram, write the angles in everywhere, and just make sure it's all really nice and clear. Okay, so this shape here, we have a compound sort of shape here that's put, what that means is two shapes that have almost been put together to form this new, and it kind of looks like a little bit of a stairs. Now what we can actually do is we can chop up the cross section into two different shapes, and if we just have a look at the cross section here, we have this L-shaped sort of, what's it, how many sides has it got? 1, 2, 3, 4, 5, 6, so it's a hexagon. So we've got like this L-shaped hexagon. Now there's two ways that we can split this up. We can either split it up going across here and make that little rectangle on the top and the larger rectangle on the bottom, or we could split it going down this way, and again just having two rectangles there. Now, it doesn't really matter which way we split it up, both will work as long as we can get the area of that cross section. And what can really help is obviously just drawing that as a 2D shape and just sort of visualising it to the side to get the area. Okay, so I'm just going to put all the lengths on. We've got 5, we've got 7, we've got 11 down the bottom, and 4 on the right. Now obviously if we are going to split it up going downwards, which I'll go for now, then we just need to find out some of the missing lengths. Now the rectangle on the left there we can work out, we've got 5 and 7 as the lengths, but the one on the right here we are missing this length just here, so we're going to need to work that one out. Now the length down the bottom is 11, and this little one at the top is 5, so that must be a missing length of 6. There we go, 5 and 6 add up to make 11. And now we can work out the area of those two shapes. The rectangle on the left, we've got 5 and we've got 7, so if we do 5 times 7, that gives us 35, so the area of that is 35. And the one on the right here, we now have our 6, let's have a look, just going across, we've got 6 going across and 4 going down. So that's going to be 6 times 4, which is 24. So we have our two areas there. Obviously we want the combined area for this cross section here. So if we add those two together, we have 35 plus 24, and that gives us a total area of the cross section of 59. Okay, so if we get rid of that and just draw that onto our diagram here, we know that the area of that cross section is 59. Now again, just like before, once we've got the area of the cross section, which in this case is this L shape here, we're going to multiply that by the depth. And in this case, the distance it goes back through the shape, this one here, is 20 centimetres. So what we're going to do is multiply that by 20. And again, you can use a calculator for this. It might not be a calculator question, but we can use calculators when we're having a practice here. So 59 times 20, the 2 times 59 is 118, add on the 0, that is 1180, and again not forgetting your units, so important that, centimetres cubed. Always just have a look in the question, identify what those units are, and in this case it was centimetres, so our volume there is going to be in centimetre cubed. Okay, so for this one we've got a slightly different type of prism, and in this case you would be given a little bit more information here, but it would tell you the shape of this cross section just here. Now you'll see that on the one that you practice, but for the purpose of practice I've minimised the amount of information here. But that cross section there is a trapezium. So when we're working out this one here, we need to get the area of a trapezium, so you need to know the formula for that as well. Now with the area of a trapezium, I have a little formula that we have is a plus b, which is the two parallel sides. We need to halve the sum of those and then multiply it by the height. And again, this could be written in different ways. We can have half brackets a plus b times h as well. So it doesn't matter which way you use the formula. Again, I'm just going to use it in this way where we divide by 2 first. So if we look at the two parallel sides, in this case that's the 6 and it's the 8. In order to get the area of the trapezium, we first add those together. So 6 plus 8, we're going to divide that answer by 2 and we're going to multiply it by the height between them, and that's the perpendicular height. And in this case it gives us the perpendicular height there, it's 5. So we're going to multiply our answer to that by 5, and that's going to give us the area of the trapezium. So working this out then, 6 plus 8 is 14, so we have 14 on the top divided by 2, and that is 7. So 7 times 5, so our area of that trapezium is 35, obviously centimetres squared there, but we're going to work out the volume. So obviously now we've got the area of the cross section, how far does it go back through the shape? And we have a distance of 20 centimetres there. So to finish this off, we take the area of our cross section again, 35, we multiply it by the 20, 2 times 35 is 70, add on the 0, and we get 700 centimetre cubed as our final answer. So again, a lot of similarity between all of these. Again, all we did was work out the area of the cross section and then multiply it by the depth. As you can see, we've got a different shape again. So we've had the rectangles and the squares, we've had the triangles, and now we're finishing off here on a trapezium. So I've got one question for you to practice. So again, obviously you need to make sure that you have this formula here, a plus b over 2 multiplied by the height, where a and b are the two parallel sides, and then you should be able to tackle this final question. So let's have a look at it now. Okay, so for this question, we actually have an easier volume to work out, but the concept of the question is different again. It says here the diagram shows a fish tank in the shape of a cuboid, and hopefully we know with a cuboid the volume of that is obviously nice and easy for us to work out. It says the dimensions of the tank are 50 centimetres by 32 centimetres by 20 centimetres, and again that's shown to us on the diagram. It says the tank is 3/4 full of water and sand, and again we can see that, and the ratio of the volume of water to the volume of sand is 5:1. Work out the number of litres of water in the tank. Now first thing first, what comes out or stands out to me here is obviously that our units are given in centimetres and it's asking us about litres. So we're actually going to have to use one of our metric conversions here and actually figure that out for ourselves. It's not been given to us, so it's something that we need to know in this question, and we'll discuss that in a little bit. But for this question here, again, we are looking at the volume of this tank. And again, there are two different ways that you could approach this. Now, I think the easiest way to approach this is to first think about, well, what's the volume of the tank if it was full right to the top? And that's easy enough for us to work out to get started on this question. And that's just to work out the volume of the cuboid. Now we know with working out a volume, we need to work out the area of the cross section. When it comes to a cuboid, you can do a little cheat and you can just multiply all the numbers together, but we should really work out the area of the cross section and then multiply it by the depth. But in the case of this question, particularly as we're going to practice this non-calculator, I think it's actually easier, and I don't like doing it, but picking the two easier numbers to multiply to start with, 20 times 50. And if we do 20 times 50, 2 times 5 is 10. Let's just write this down. 20 times 50, 2 times 5 is 10, and add the two zeros and it becomes to 1,000, and that just makes it nice and easy to then multiply that by the 32. So to get the volume here, we can do 32 multiplied by 1,000, and that gives us a total volume there of 32,000. There we go. And not forgetting our units there, that is centimetre cubed. Now it's up to you what approach you take at this point. We could start working out then what 3/4 of that is to figure out what volume of the tank is actually filled up, and then having a look at this ratio. And as you can see, obviously, although we've got volume involved, we've also got fractions and ratios and also conversions involved in here as well as having to obviously break this all down. Now I think the easiest thing at this point is probably just to turn this straight into litres, and the unit conversion that you need to know is 1,000 centimetre cubed, okay, is equal to 1 litre. Okay, so that's one of the important unit conversions that we need to know, and it might not necessarily be given to you, so it is one that you need to know, just like on the last one, that 1 metre cubed was 1,000 litres. So for this one here, definitely a little key point to make sure that you've got there, 1,000 centimetre cubed is 1 litre. Now for the next stage of this, we need to obviously turn it into litres. So in this sense, we have 32,000 centimetre cubed. So if we want to turn that into litres, the opposite of what we did last time, this time we're going to divide it by 1,000. And if we divide that by 1,000, we can knock off the 3 zeros and we get 32 litres. There we go. And there is the volume of our full tank. Now obviously the next piece of information in the question said to us that the tank is 3/4 full of water and sand. So if we find 3/4 of 32, we'll be able to find out what quantity there is actually the water and the sand. So if we find 3/4 of 32, there we go, 3/4 of 32, and that's easy enough for us to do. We just divide by 4 and times by 3. 32 divided by 4 is 8, times that by 3 is 24. So we have 24 litres, there we go, that's our water and sand. Now you can imagine at this point, if I hadn't have done this conversion straight away, I would have had to have found 3/4 of 32,000, which isn't necessarily more difficult, but it is a little bit more fiddly there with the larger number. So it's probably better for us to have made that conversion straight away. So just something to be thinking about in that question there. We now know how much is full up with water and sand. Okay, that's up to this point here where the water stops. And then it tells us in that last piece of information there that the ratio of the volume of water to the volume of sand is 5:1. So essentially all we need to do is take that 24 litres that we have and split it in the ratio 5:1. Now hopefully you remember, obviously with ratios, we're going to figure out how many parts there are in total, and that's 6 parts. So if we do 24 divided by 6, we'll be able to split that up in the ratio. So let's write this out. So 5:1, and we're going to figure out what we're going to multiply both of those by. So 24 divided by 6, our total amount of parts there is 4. So we're going to multiply both of these numbers by 4 to get our corresponding litre values. So 5 times 4 is 20, and 1 times 4 is 4. And again, remembering just a quick double check there to add those two together, make sure it adds up to our original amount, which it does, 24. So in terms of answering our question here, look, just remembering that the 5 was the water, the 1 was the sand, and it wants us to work out the number of litres of water in the tank, and we've got that right there, 20. So there we go, our final answer there would be 20 litres. Now again, with all these different types of questions, there is another way of doing it. What we actually could have done, and I don't think I prefer this method, but it is a nice method that you could use, you could actually just look at the height of the tank. So the height of the tank, we know it's only going to be 3/4 full up to there. So you could find 3/4 of 32, the height, and that would give us a cuboid that's just in the shape of the sand and the water. You could even then go a little step further and you could split that height up in the ratio of 5:1, and you could just find out what the height of the water is. And I think if we were to do that relatively quickly, 3/4 of 32 we already knew was 24, so the height would have been 24, and then when we split that into the ratio 5:1, the height there is only 20. And if we do 20 times 20 times 50 and multiply that all out and turn it into litres, we could actually take that approach as well. And that's quite a nice approach that you could also have a think about, and you could have a try of obviously trying to work it out that particular way. But I think that that way was maybe not quite as intuitive as just working out the volume and splitting it up from there. But there we go, another question, another way of approaching it. Obviously some discussion on different ways that you could have approached it along the way, whether you convert it straight away or not, or whether you look at the height and go for the volume of the cuboid that's just the water. It's completely up to you. But I think that was the easiest way and the most logical way to go about working this out. Now we're going to be using a calculator as well, so make sure you grab a calculator. Now it says here, work out the volume of the cylinder and give your answer to 3 significant figures. Now as I mentioned, we're going to be using the same principle as before. Okay, so we're going to look at the cross-sectional area, which in this case is the circle sitting on top. So in order to work out the area of a circle, we need to make sure we know the formula for the area of a circle. And the formula for the area of a circle is area equals pi r squared, where r is the radius. Now this question has given us the radius. Sometimes a question might give you the diameter. It might have said that the full length across was 22, and in which case we would need to halve it in order to achieve or get the radius there. So to work out the area here, we're going to do pi and multiply that by the number we've been given, which is 11 squared. There we go. Now depending on which calculator you've got, that might give you the answer 121 pi, so you're going to need to turn that into a decimal, but again you might not have a calculator that actually shows that functionality. It is quite a handy function if you have got one, and it is worth investing into a Casio calculator. Again, I'll put some links in the description if you want to check some out. But there we go, there's our answer, 121 pi. And I'm going to write the answer as a decimal just in case anyone is using this and doesn't have a calculator that shows your answer like that. And ultimately we've got to give our answer to 3 significant figures anyway. So that answer there comes out as 380.1327111, and that is the area of the cross-sectional area up there, which is a circle. Now in order to work out the volume, just like we did on 3D prisms when we were looking at the volume of a prism, we are going to multiply it by how far that face goes through the shape, in this case that is the height of the cylinder, so that's going to be 30 centimeters. So we take the area, multiply it by the height, which is 30, and we're going to get a final answer there. So if we multiply that by 30 on the calculator, again we get an answer in terms of pi, but if we just write down the decimal version, we get 11,403.98133. So there is our volume. Obviously that's going to be in centimetre cube, so we won't forget that when we write our final answer, but we need to round this to 3 significant figures as we've been asked in the question here, and we're going to be looking at 3 significant figures throughout all of these questions. So in order to round that to 3 significant figures, we're going to go from the first whole number 3 along, so 114, chop it after the 4, and in this case the number that we've chopped after is in the hundreds position, so actually we're going to be rounding this to the nearest 100. So 3 significant figures in this case will be the nearest 100. So that's going to be, as a final answer, 11,400 centimetres cubed. And there is our final answer for the volume of a cylinder. Okay, so hopefully nice and easy. It links in very nicely with the volume of prisms in the video that I mentioned before. We're just going to work out the area of the cross section, which again in this case is a circle, and then times that by the height. Okay, so the surface area of a cylinder just requires a little bit more working out. Obviously we're looking at area, so it's going to be a little bit different anyway, but we have just got a little bit more working out when we're working out the surface area as opposed to when we're working out the volume. Now when we're working out the surface area, we're going to work out the total area of all the different surfaces. And you can see we've got a circle on the top, and we've already been working out the area of that, and the one that you can't see that's on the bottom. If I try and highlight that in, you've got a little circle down there as well. So we're going to have to work out the area of those two. Obviously they're both identical, so we only need to focus on the one on the top, and then we can double it up. And then we also have another surface here, and that is the curved surface going around the outside of the cylinder. And we'll talk a little bit more about that in a sec. But if we start with the circles, as we've already been working those out, we should be able to get those done nice and easily. So for the area of the circle, obviously it's pi r squared, so we're going to do pi times the 9.3 squared, and that's going to give us the area of the circle. And if we write that into our calculator, what have we got? 271.716. Now it wants the answer to 3 significant figures, so what I'm going to do is I'm just going to keep my answers to about 3 decimal places, which in this case for these looks like it's going to be about 6 significant figures for this one, but I'm just going to keep it to a much higher degree of accuracy than we want in our final answer. It's good practice just to write them all down, but I think we'll be absolutely fine keeping it to those 3 decimal places. So we've got 271 point, and we get 716. Now, and there's obviously a few more decimals after that. Now obviously we're going to double that up as we have 2 of these circles. So if we times that by 2, that's going to give us the total area of those 2 circles. So I'm just going to do times 2 on my calculator straight away, and there we go, we'll write down these. So we have here 543.43, and actually when we double the answer that I had on the calculator, that's going to round up to 433. Okay, so there we go. There is our answer on the calculator. Obviously there's a little bit of difference there. Obviously with the number above, I've not actually doubled that number, I've doubled the one on the calculator. But if I was to just, in fact let's just write everything down just to avoid that little bit of confusion there. So we have 4326972. That's the full answer that I've got on my calculator. So that is the total surface area of the 2 circles. Now we need to have a look at, as we mentioned, the curved surface around the outside. Now if you imagine that if this was like a hollow cylinder and we took a pair of scissors and we cut down the centre just here and we unravelled the cylinder and flattened it out, what we would actually have is a rectangle. Okay, so we would have a rectangle, it would have a length here of 12.4, the height of the cylinder, but we would need to work out the length going along the top. Okay, this length just here. So in order to get that length there, if we look at our cylinder, that length there is actually the length that's going around the outside of the top there, around the circumference of the circle. So actually that length that we're trying to work out on the top of that rectangle, let's see if we can get rid of that arrow there, is actually just the circumference of the circle. And the formula for circumference is pi times diameter, or pi times 2r, depending on which formula you use, but this one seems to be more recognised, so we'll go with circumference is pi times diameter. Now obviously that means we need to know the diameter of the cylinder here, and we've got 9.3 as the radius, so if we double that we get 18.6 as our diameter. So in order to work out the length along the rectangle there, we can do pi and multiply that by 18.6. Obviously that has a numerical answer, but I'm just going to leave it as pi times 18.6. So to get the area of the rectangle, that's nice and easy, it's just length times width. So if the length is pi times 18.6 and the width is 12.4, if we multiply those all together, let's see what we get. Pi times 18.6 times 12.4, and that gives us a final answer of 724.576. And what else have we got? 9296. There we go, just about fit that in. So that is the curved surface area around the outside of the cylinder. Now obviously we need to add these all together to get the total area, so we're going to add these two numbers together, and that's going to give us our total surface area. Let's just put a little plus there. Obviously just being careful with this sort of question, we're going to add those up in a sec, but obviously just being careful that that curved surface area there, we're getting the circumference as the length of that rectangle. I think that's the difficulty here, remembering to do that when you've got this type of question. But there we go, that's how we're going to work these out. We just need to finish this off by adding those together. So I'm going to do that inside the cylinder there. So we've got 724.576, the curved, plus the two circles, 543.4326.972. There we go, pressing equals, and we get a final answer here of 1,268.009627. And again, three significant figures. So let's round that off. 126, the number in front of the line is the nearest 10, so that's going to be 1,270, and again it's about area this time, so that's going to be centimetres squared. So there's our final answer, 1,270 centimetres squared for our surface area. Okay, so obviously you've got the two circles to work out and the curved part using that circumference for the length of the rectangle. So it says work out the length of the arc AB. So from A to B is this arc right here, and that's what we're going to work out. Now when we're looking at the length of the arc, we're looking at part of the circumference, and the formula for the circumference is circumference equals the diameter times pi, or pi times diameter. Okay, so that's all we're going to do. We're just going to do pi times diameter, but then we're going to look at it as a fraction of the whole circle here, because obviously this is only part of a circle, and we're going to have a look at what fraction it is. Now the key part of that in figuring that out is this angle right here. So we've got 40 degrees at the moment, and we know that in a circle there are 360 degrees, so the fraction of the circle that we're looking at here is 40 out of 360. Okay, and that's what fraction of the full circle we're looking at. So in terms of the length of the arc, that is the fraction of the circumference that we're actually going to be finding. Okay, we're going to be finding 40 over 360, lots of the circumference. Okay, and we could go about simplifying that if we wanted to, but we're going to do this all on the calculator, so there's no need for us to be simplifying these fractions. So in order to work out the full circumference, I first need to know what the diameter is. Now this particular question, as it's a sector, tells us the radius. Okay, it says the radius there, which is 7, and the diameter is double that. Okay, so we're going to double that for the diameter, so the diameter is going to be 14. So to work out the full circumference, I would do pi and I would times that by 14. Okay, and if I work that out on the calculator, let's have a look what it comes out as. Pi times 14 comes out as 43.982. Now that's fine, that's the full circumference, but I only want part of it, and I've already established that it's 40 over 360. So straight away on the calculator, rather than working that out, I'm just going to times that by the fraction that we're looking for, which is 40 over 360. There we go. So if I type that in, say pi times 14 times 40 over 360, and I get my final answer there, and that comes out as 4.886921,906. There we go, and we'll write all those numbers down. Now obviously it says in this question, and it'll always tell you a specific way to round it, and here it says 3 significant figures. So if we round that to 3 significant figures then, so 488, chop it after the 8, there we are, it's a 6 afterwards, so that's going to round that final 8 up there, so that is going to be a final answer of 4.89. There we go, and just have a look in the question, it's centimetres, so that's 4.89 centimetres, and there we go, that's our final answer. So all you've got to do is obviously have a good understanding of the formula, so circumference is pi times diameter, and then obviously looking at what fraction of the circle you've actually got in front of you when you're looking at one of these sectors. So there we go, all we did was circumference is pi times diameter, multiplied it by 40 over 360, and that gave us the length of the arc. Now a question like this might also ask you to find the perimeter, so at the moment we've established that this length here is 4.89, but if it did ask us to find the perimeter, that would be the full length all the way around. So the yellow line that I've highlighted is 4.89, but then we also have these two lengths here, which are both 7, and we would add them all together to get the perimeter there. So 7 plus 7 is 14, plus the 4.89, that come out as 18.89 for the full perimeter. But again, this question was only asking for the length of the arc, but just thinking about different things that you could actually be asked to find on a particular question like this. Right, okay, so we're going to have a look at working out the area of a sector. Okay, so once you've obviously got to grips with that previous question, looking at the length of the arc, working out the area of a sector isn't really any more complicated, okay? Because the area of a circle, which we'll write down here, is pi times the radius squared, or pi r squared. Now when it comes to this sort of question, obviously we just need to make sure that we are establishing what fraction of the circle it is again, and this is a major sector here. We've got quite a large sector, obviously thinking about the size of the full circle. Yeah, we've got a little sector there that's been chopped off, but we've got quite a big sector that we're actually working out the area of. Okay, so the actual sector we're looking at, the angle for that is on the other side just here. So we're going to have to take that 100 away from 360 to establish what's left, and that is 260 degrees. Okay, so that's the fraction of the circle we're looking at, 260 out of 360. And let's just label that so we know that. So that's 260 out of 360. So we're going to follow the same process. Obviously this time it says work out the area of the sector. So we're going to do pi times the radius squared. The radius is down there, 4, so times 4 squared. And then again, just times by the fraction that we're looking at, which is 260 over 360. And typing that into the calculator, pi times 4 squared times, and let's just type that in, 260 over 360. And that gives me a final answer here of 36.3028, quite a lot of decimals here, 30284844. There we go. And again, we're going to round this to 3 significant figures, as it says up here. So let's round that off. So 363, chop it after the 3, it's a 0 there, so that's going to stay the same. So we've got 36.3, and that is centimetres squared. There we go. Obviously for an area we need to make sure we get the right units in there. So 36.3 centimetres squared is our final answer. So there we go, that's all you need to do. Obviously you just need to know those two formulas, whether you're asked for the circumference, which is where you're going to do pi times diameter, or if you're asked for the area, and we're going to do pi times the radius squared. Okay, now both of those, we're obviously going to multiply that by whatever fraction we're looking at. So when it comes to the sector here, we'll call that angle x over 360, and the same for the one below. There we go. But that circumference and area formula are key to remember, and then obviously just thinking about what fraction of the circle it is that we're going to multiply it by. Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here, and it says give your answer to correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes, if we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base, that creates a right angled triangle here on the right, and we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here. and that's in meters, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angled triangle now, we've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angled triangle we've got the hypotenuse look opposite our right angle. So we're going to do square, square, and then minus, and then root. So 3.2 squared, take away 1.9 squared. We'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in meters this time, so 2.57 meters, and I can label that down here, 2.57 meters. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 meters, and there is our final answer for that question. Okay, so this question says work out the length of BC and give your answer correct to 3 significant figures. Now looking at the question, BC is this side here that we're trying to work out. So first things first, I'm just going to label the triangle. So opposite the angle is my opposite, so we're trying to work out the opposite. I'm going to shorten that to just OPP for op. And then I'm just going to label this other length here. Now we've been given one of the lengths, and that's 8.7, so I'm going to label that one. Now it's not the hypotenuse is here, if we label that with a HYP, opposite the right angle, so that one there is my adjacent, which again I'm going to abbreviate just to ADJ. Now we only actually need 2 of these letters now, okay, and the one letter that we do need is the one with the side we've been given, so we need the adjacent, and we're looking for the opposite, so we need to use the opposite as well. So actually I don't need to use any formula with the hypotenuse in for the purpose of this question. Now the next thing I need to do is decide which formula I'm going to use. So I'm going to write down my 3 formula triangles, SOH, CAH, TOA. And all I'm going to do is I'm going to pick the formula triangle that has the A for the adjacent and the O for the opposite in. And if you have a look at those 3 formula triangles, that is my tan triangle, TOA. Okay, so now we just have to think how we need to use it. Now if you've used formula triangles before, you'll know I just cover up or cross out the one that I'm looking for. And in this case, we're looking for the opposite. So if we're looking for the opposite, we cross out the O. And that means I've got T and A next to each other, and that means that I have to do a multiplication. Okay, so if they're next to each other, we do a multiply. So what I need to do is I need to do T times A. Now, we just need to know what T is. Now, T stands for tan. Remember, S, C and T stand for sin, cos and tan, which are basically just buttons on your calculator, but I need to figure out what goes with tan. Now, whatever angle I've got in the question, that's what goes with tan, and I'll explain why. Okay, so when I put this into my calculator, I'm going to put in tan 36, and 36 needs to go in a little bracket, and you need to close the bracket there. Now when I type that into the calculator, and if you're following along with me, I'm just going to type that in now, tan 36, you get a decimal on your calculator, and that decimal comes out as 0.7265. And if I just write that down, 0.7265, there's a few more decimals there, but it's just important to understand what that decimal actually means. Now all that means is that's the relationship between these 2 things in our formula triangle, and that was the O on the top and the A on the bottom. So tan 36 tells us the relationship between the opposite and the adjacent side, and 0.7265 as a percentage is around between 72 and 73%, and all that means is that for this particular angle, the one side is going to be between 72 and 73% of the other, specifically 72.65 and a bit more percent, but one is going to be that much smaller than the other. Okay, and doing this calculation is going to basically work that out for us. And we can think about it logically, but we already know we're going to do a times, so we've got tan 36 on the calculator, and we're going to multiply that by the adjacent side, which is 8.7. So tan 36 times 8.7 is going to give us our answer. And thinking about this logically, if you multiply 8.7 by 0.7265, that number is going to get smaller. And if we do it on our calculator, let's go for it. Tan 36 times 8.7, we get the answer here, and let's write it down, 6.3209199994. There we go. And we are going to round this in a second as well because it wants it to 3 significant figures, but there we go, that gives us our answer, and logically you can see that that's going to make sense. Now it's kind of hard to tell with the opposite and the adjacent which one's the bigger or the smaller side, but when it comes to looking at the hypotenuse, you can normally tell that it's going to make sense because obviously the hypotenuse has to be the longest side, and we will have a look at that on the next question. But for this question here, 3 significant figures, I'm going to chop that after the third significant figure there, which is the 2, and I get a final answer of 6.32 centimetres. And there's the final answer for this question. So just very quickly, thinking about what we actually did there. Step 1 was to label the sides, and we only labelled the 2 that we needed, one that was given to us and one that we were looking for. Then we picked out of our 3 formula triangles there, which you do have to know off by heart, which one had those 2 letters in. So it was the O and the A, which had tan in, which was in the tan triangle. So then we were able to figure out which one we were looking for. We were looking for the opposite, so we crossed that off, and it showed us here that we had to do a times. So when they're next to each other, we do a times. And then we just plug that into the calculator. So tan 36 times the adjacent, which was 8.7. And it's very important that you do always put the angle with the tan, whether we're using sin, cos or tan, because that's what tells you the relationship between those 2 sides with that particular angle. Now you are going to need a calculator for this again, because we're going to be looking at only calculator-based trigonometry here. But it says work out the size of angle x and give your answer correct to 1 decimal place. Now again, labelling the triangle from that angle, 5 is our opposite. So 5's our opposite, and 12.5 is our adjacent. Again, with that side R to P being the hypotenuse, but we don't need it, we only need 2 lengths. Now O and A appear in the tan formula. Okay, so if I write TOA, my formula triangle, and think about what I'm trying to do here. Now when I'm finding an angle, we cross off the T, and that tells me that it's O over A. Now there's one extra button that you have to press on your calculator when you're trying to find an angle, and that is before you press tan, we press the shift button. You don't have to hold it down, you just have to click it. So you click shift, click tan, and it comes up with tan minus 1. And depending on what calculator you've got, it normally opens up a bracket. If it doesn't, just open it up yourself. Okay, so in there we need to do O divided by A. So O over here is 5 centimetres, so 5. A down here is 12.5, so 5 over 12.5, and then just make sure you close your bracket. And again, if you don't have a calculator that has a fraction button, you can just press 5 divided by 12.5 in the bracket there. So if I do that on my calculator, 5 over 12.5, press equals, and we get 21.801 and a few more decimals, but it only wants it to 1 decimal place, so I'm not going to bother writing them all down. Okay, if you don't have a calculator that does your fraction button there, you might just want to check out the calculator that I advise in my description, but completely up to you. But there is one in there that I'm using right now. Okay, I use a couple of calculators that I use. I tend to use the Casio ClassWiz calculator, but it's completely up to you what you decide to use. You don't have to have one of these. You can just press 5 divided by 12.5 in the bracket there. So locking that off to 1 decimal place, we get 21.8. There we go. Oh, that's not 21. Here we go, 21.8, and it's a amount of degrees, so we put degrees there and just highlight that. There we go, 21.8. Okay, so we're going to have a look at one more where we're finding an angle, but it's the same process, potentially just using sin, cos or tan like we did in this one. Okay, once we've labelled the sides. Okay, so a slightly different question here. We've got some negatives in our vectors. We've got a negative on the top of A and a negative on the bottom of B. So that indicates a left movement of 2 there for vector A and a down movement of 1 for vector B. And it wants us here to write down 2A minus B as a vector. So we're going to do the vector 2A. So let's do that one to start with. We've got 2 lots of, and then we have minus 2 and 5. And we're going to take away from that vector B, which is 3 and minus 1. Okay, let's sort out this 2 lots of vector A to start with. So doubling both of those, we have minus 4 over 10. Okay, so just doubling those, and we're going to take away this 3 over minus 1. Now we're going to deal with the top numbers to start with. So let's just think about this numerically. We've got minus 4, and we're going to take away this time, we're going to take away 3. So minus 4, take away 3, leaves us with minus 7. And on the bottom there, we just need to be careful because we're going to be doing 10 and we're going to take away that negative 1 on the bottom. So taking away a negative, that's obviously going to add 1. So actually we're going to do 10 add 1 here, and that's going to be 11. And there we go, there is our final vector, minus 7 over 11, written as a column vector. And it says in the question here, the vector A and B are shown on the grid. And we've got vector A that we can see there going sort of upwards to the right, and vector B that we've got going downwards to the right as well. And it says for part A here, on the grid, draw and label the vector minus 2A. Now obviously 2A will just be double the distance of A. The fact that it's put a minus in there means it's going in the opposite direction. So instead of our arrow pointing upwards, it's going to be kind of coming downwards to the left. So in terms of looking at this, we just need to establish what the pattern is of A just to make sure that we draw this in correctly. And you can kind of see if we start from a certain point, we need to go across 1 and we go up 2. There we go, let's draw that again. So we go across 1 and we go up 2. Right, so in terms of actually getting the pattern here, we just need to pick somewhere, hopefully not somewhere where it's going to overlap with A. So let's start down here. There we go. And we're going to go across 1 up 2, which gets us to there, across 1 up 2 again, and that will get us to there. Okay, so let's rub that out. So in terms of actually drawing the line in, that would be the vector 2A, double the distance of A and following that same pattern across 1 up 2. The fact that we're doing minus 2A just means we need to point the arrow in the opposite direction. So there we go, we can label that. That would be the vector minus 2A. And there we go, there's part A done for that one. Now for the other one, we've got to work out the vector A plus 2B as a column vector. And the process of looking at the pattern is really going to help us for this. So we looked at the vector A to start with. Now that vector A, and we can write this down over here, the vector A, it went across 1 and up 2. So that would be 1 in the positive right direction, and then 2, obviously being a positive in the moving upwards. So there's our vector A, 1 over 2. Now the vector B, let's have a look at that one. So from the start, obviously it's going downwards, this one, as shown by the arrow. That's going to go across 1, so a positive 1, and then it goes down by 3, so that'll be negative 3. So the vector B, if we write that in, B is equal to 1 over minus 3. So now we've established that, we can just treat that like we did in those earlier questions. We're going to do an A, and we're going to add to that 2 B's. So in terms of writing this one out, we've got A, which is 1 over 2, and we're going to add to that 2 of the B's, so that's going to be 2 lots of 1 on the top, which is 2, and 2 lots of minus 3 on the bottom, which is minus 6. There we go, and we can add those together, so 1 plus 2 on the top gives us 3, and then 2 add negative 6 on the bottom. Well, when we add negative, that's going to take that away, so that'll be minus 4 on the bottom. So our final vector will be 3 over negative 4. And there we go, that's how we're going to approach these vectors when they're on a graph. Obviously we can just turn the vector into a column vector and treat it just like we did on the previous questions. So it says enlarge the shape by a scale factor of 2 from the centre 1, 1. Now obviously we need to just identify that coordinate first, so across 1 and up 1 gives us a centre of enlargement just here. So this is where we're going to enlarge it from, and I almost kind of imagine this like a little bit of a torch, and it's currently projecting this image here that we can see on the grid there. Now what we're going to do is we're going to obviously project it somewhere else. Now a scale factor of 2 means it's going to get twice as big. So it's going to be projected twice as big somewhere else within this grid. Now there's a little process to go about actually finding where it's going to be projected. Now all I do is I just find one of the points to start with. Now I can pick any of these points. I'm going to go for this top left one just here. And all I want to think about is at the moment from this little projection point, the little cross that I've got in red there, how do we get to that little cross that I've highlighted there in the green? Now if I look at how I actually get to that, I go up 1, 2, 3 and across 1. So that was 3 up and 1 across. Now for a scale factor of 2, all I'm going to do is think of that as a movement. You could always think of it as a vector, and I'm just going to double that. So at the moment it's going up 3 and across 1. Now if I want to double that, obviously, which is what we're going to do for a scale factor of 2, instead of going up 3 I'm going to go up 6, and instead of going across 1 I'm going to go across 2. So going back to the original place, and I'm just going to get rid of these lines here. So back from the original sort of like torch or centre of enlargement, if we're thinking about it from there, I'm going to go up 6 from that point. So 1, 2, 3, 4, 5, 6, and I'm going to go across 2. So 1, 2. And that right there is where that point is going to go. Now, obviously, we could do this with all of the points. So there's obviously 3 other points there that I could look at. We could do this one here, we could do this one here, and we could do this one here. But actually, I can get away with not doing any more once I've done that first point there, and I'm happy with where it's positioned. So all I'm going to do is I'm going to draw the shape in twice as big from that point. Now, the only thing you have to be careful of is obviously the point where we are was this point just here, so I don't want to redraw the shape from any of those other 3 points there. I just want to redraw it from that one point. So at the moment it's 2 across, so it's getting twice as big, so it's not going to be 2 across, it's going to be 4 across. So I'm going to draw this in a different colour. So we're going to go 1, 2, 3, 4 across. Now at the moment it's 3 down, this one here, 3 down, so that's going to be 6 down. So from that point I'll go 6 down, 1, 2, 3, 4, 5, 6, and don't worry if it is overlapping at any point. The one bit down the bottom there is only 1 across, so that's going to be 2 across when we double that. And then we just need to connect those up. Now we've got all of those sides drawn in. There we go, and connecting that up. Now it might ask you to obviously label it a particular letter or something like that, and obviously this question doesn't. But if it is actually to label it, obviously just stick your label inside there. You don't need to worry about shading it in or anything like that. What's important is that those corners or the vertices are in the right places. And that's all we have to really do for an enlargement. So we pick a point, move it via that scale factor, and then draw it in however much bigger that it's asking for in that particular question. But there we go, that's that first one. Let's have a look at just applying this on some other questions. But as you're going to see, I'm going to follow this very similar approach. There are other approaches. I know you can do things like the ray method. You can draw sort of lines coming out the centre of enlargement. I find it a little bit more confusing this way though. I think this is just a nice simple way of completing an enlargement. So it says in this first question, James invests £4,000 for 3 years in a savings account and he was paid 2.4% compound interest per annum. How much did James have in his savings account after 3 years? Okay, so first thing we need to have a think about here is the fact of what compound interest actually means. So compound interest, this word here, means that the interest he earns in his first year then goes towards the amount of interest he can then earn in each subsequent year. So after he earns this 2.4%, let's just imagine that's £50. In the second year, he'll earn interest on £4,050. Okay, so his interest keeps getting better and better. And this is such an important topic. This is obviously very closely related to how you earn money in real life and how compound interest works. So I actually think this is probably one of the most important topics that you learn at GCSE maths, and it's one that I actually really enjoy teaching. So we're going to have a look at this question, how we approach it. Now, first of all, we are obviously going to look at calculator methods, as I said, and this 2.4% is very important here because we need to know how to write that as a percentage. Now straight away, just as a decimal, and if we want to write 2.4% as a decimal, it's obviously going to be 0. And then for 2% it would be 0.2, and then for that extra 0.4%, although there's a decimal in the percentage, we don't introduce another decimal within our decimal, so it's just an extra 4 on the end there, and that is the decimal version of 2.4%, 0.024. It's very rare that you'd ever get a double-digit rate of interest, so it's pretty much always 0.0 something. Okay, so just always remember that, because if you put 0.24, that's 24%, and it's very rare that you're ever going to get 24% interest anywhere. If you do, let me know. But 0.024 is our decimal version of this. Now, in order to actually increase by an amount, instead of putting a 0 here, so instead of having this 0 at the start, we can change that for a 1. The reason being that if you times something by 1, it obviously just becomes itself. 4,000 times 1 is 4,000. But if you times it by 1.024, add on that extra 2.4% as a decimal, it'll actually increase it for you. And you can try that on your calculator. If you do 4,000, let's write it down, and you multiply that by 1.024, it'll add on 2.4% for you. So I'm going to do this on my calculator now. 4,000 times 1.024 equals £4,096. So that's an extra £96. Now if you just do 4,000 and you times it by 0.024, you'll see that you get £96. Okay, so you can try that out. 4,000 times 0.024, you'll get £96. So adding the 1 in there instead adds it on for us. It does that job for us rather than having to write it down and add it on. You straight away get 4,096. Now that's great if it's 1 year, but this says 3 years. So what I actually want to do is I want to times by 1.024. I want to get my answer, times it by 1.024 again, get my answer and times it by 1.024 again. And you can do that, you can type it in 3 times. If I do it now, times another 1.024 and then times another 1.024, we end up with a final amount of £4,294 and 97p when we round it up to the nearest penny. Now rather than actually wasting all that time, because I do want to teach you the fastest way here, to make your calculator times it by itself 3 times, we can just put a little power of 3 there. So however many years it is in the question, in this case it was 3 years, we can just put a little power of 3 there, and that actually does it for us. So if you go ahead and type that in, 4,000 times 1.024 power of 3, press equals, and you get the answer, £4,294, and it's 967, but we'll round it to the nearest penny, 97p. Okay, you could actually make an argument that it'd be 96p. It's often the case that banks won't round it up for you, so you could make the argument it's 96 or 97p, but following the normal mathematical rules of rounding, we'll round it to 97p. Okay, so obviously just write in your final answer with your pound sign. You've got £4,294 and 97p. And that's what's in the bank there after the 3 years. Okay, so we take our starting amount, we multiply it there by our multiplier, not forgetting to add the 1 in. So 1.024 will add on 2.4%, and our little power there is the amount of years, or the amount of times we want to times by 1.024. Okay, so this question says, Amy buys a new car for £18,000. Each year the car depreciates by 12%. How much will the car be worth at the end of 3 years? And obviously we could do this without a calculator, but we're going to have a look at doing some calculator methods here. So obviously the original value in terms of a percentage is 100%. Now if it loses 12%, so let's just say, okay, well we lose 12%, what percentage are we actually left with? And 100 take away 12 is 88%. Now there's actually something we can do here, because if it's going to be 88% of its value each year, there's something we can just times by straight away on the calculator, and it's the decimal version of 88%. And the decimal version of 88% is 0.88. And straight away, if we just times by 0.88, it will actually take away 12% for us. I can do that on the calculator, 18,000 times 0.88, and it gives me the answer 15,840. So that would actually just reduce it for me in the first year. And I could just do that 3 times. I could just times by 0.88 and keep on repeating that. Or I can actually do something to speed things up a little bit. And it's very similar to compound interest. And with compound interest, this is something that you add on to this multiplier here to get your 3 years. And it's a power of 3. So if I want to actually do this just 3 times very quickly on the calculator, I can do £18,000. And I can just times it by 0.88, and again I could do it 3 times, or just to speed things up a bit, you can just add a power of 3. Okay, and that will just be the same there. If it was 4 years, you'd put a power of 4, 5 years, you'd put a power of 5. Okay, and it'll just do it that many times for you. So if I type that straight into a calculator, 18,000 times 0.88 to the power of 3, and I get this answer here, I get £12,266.496. And obviously we are talking about money here, so we're going to have to round it to the nearest penny. So a final answer would be £12,266, and I'm just going to follow the normal rules of rounding, so I'll chop it off after the 9, and that rounds up to 50p there. So that 9 rounds up because of the 6, which rounds it up to 50p, so 0.50, and that'd be my final answer there. Again, just rounding to the nearest penny on any of these questions. Okay, so that's how you do it nice and easy on the calculator. Again, just thinking about the percentage, let's just pick a random one. If it depreciated by 23% each year, 100 take away 23 would leave us with 77%, and as a decimal, 77% is 0.77, so I'd times by 0.77. So just something to be thinking about there. Whatever the percentage it depreciates by, you can take that away from 100 and then convert it into your decimal that you're going to want to multiply by. So just a little bit of a quicker way that you can do this rather than having to do all those stages of each year. Okay, so this question says identical pairs of boots are sold in London, Geneva and in Paris, and the handbag costs €174 in Paris, £115 in London and 189 Swiss francs in Geneva. And it says the exchange rates are, and we've got £1 is €1.27 and 1 Swiss franc is 72 pence, or 0.72 pounds. In which city are they best value for money? Now obviously we're going to get them in the same exchange again, in the same currency, but this one here always tends to throw people because that is a bit of an odd exchange rate. That kind of exchange rate is the exchange rate we would be given if we were actually in Geneva and we were wanting to convert our money back into pounds. So it's not one that we see very often because normally it's always £1 to whatever the other currency is. So this is a little bit different, but again all we're going to do is apply a bit of logic, and this is why I don't remember just times or divide for particular ways, because if we are given an exchange rate like this, we have to think logically about the size of our answer and which one logically is going to be bigger or bigger or smaller in terms of the number. So again, I'm going to take the same approach. I'm going to leave London as it is, as £115. I'm going to look at Paris and Geneva. So I'm going to start with Paris. Okay, so Paris, we need to convert the €174 into pounds. Now again, looking at the exchange rate, okay, so down here our exchange rate, the pound is now to €1.27, so the euro number is higher. So I need to divide by that exchange rate, so 1.27, in order to get it back to the smaller pounds number. I've got to be careful with the language that I use because obviously it's the same value, but in terms of the size of the number, it is smaller. So divide it by 1.27, and I get, and it's a nasty decimal, and don't be put off by that, I get 137 point, and then it's 007. So to the nearest penny, that would be 01. Okay, so it's a 7 after that in that third decimal position. So obviously that's now in pounds, so we've got 137.01. Now we can already see that that's not better off than buying it in London, so we can also almost forget about that one now. And now we're going to have a look at Geneva. There we go, so in Geneva, let's have a look. The cost at the moment is 189 Swiss francs. Okay, so 189. Now thinking about the logic of this exchange rate, you can see that for every 1 Swiss franc we get less than 1 pounds. So we know again that the answer in pounds is going to have to be smaller, but this time if I was to just divide, which obviously some people tend to remember it like this, you divide coming back home, you times when you're going away, but because this is the foreign exchange rate, if I was to divide by 0.72, which I'll do on my calculator now, 189 divided by 0.72, I get the answer £262.50, and that is a lot higher. Okay, so when we've got the foreign exchange rate, we have to almost reverse the process and think logically, and actually it's just logically okay, well dividing didn't work, so we're just going to multiply by that exchange rate of 0.72. okay, and obviously that's what you'd do if you were actually in Geneva and you were obviously going off on holiday to London, you would multiply by the exchange rate. Okay, so it's just giving us their exchange rate rather than our own. So 189 times 0.72, and that gives me an answer here of £136.08. There we go, so it's £136.08. There we go. So actually, as you can see, all of that working out, and actually it is just best value to just to buy these boots in London. Okay, so obviously these questions will normally say you must make sure you show all your working out, and there we go, that's all our working out there. So even though it's still in the London one, we're going to say it's best value in London. There you go. The boots are best value in London. There we are. Now obviously you could have taken a different approach here, you could have converted them all maybe into another currency. It wouldn't actually, I don't think we could have done with this one in particular because we don't have any exchange rate here between them, although we could have maybe converted Paris into the Paris amount into pounds and then into Swiss francs, and also converted the pounds into, we'd have had to do it in 3 steps rather than 2. So it was the most sensible idea in this question to convert them all back into pounds, but you could have actually gone about trying to convert them all into euros or into Swiss francs as well, but just makes sense to always convert it back into our own currency. Obviously, just makes a little bit more sense when it's on the paper. Okay, so this question looks very similar. It says Tom and Amy share some money in the ratio 5:3, but this time it says Tom gets £70 more than Amy. Work out how much they each receive. So again, let's bring this away from the words. We've got T to A, and it's in the ratio 5 to 3. Now what it says is Tom gets £70 more than Amy. So Tom, who's this one here, is getting a little bit more. Now if we have a look in terms of the parts, look, Amy's getting 3 parts, Tom's getting 5, so Tom is getting an additional 2 parts to Amy. So those extra 2 parts that Tom's getting, it's saying that those plus 2 parts there are worth £70. And from there we can take exactly the same approach that we did on the last one. Okay, we can divide that by 2 to get our value of 1 part. Now again, you could think about this in terms of a picture. We could have Tom's 5 parts and we could draw 5 little circles, look, and Amy's 3. And then we can just identify in terms of the picture how many more he's getting. Well, he's getting these 2 extra here. So those 2 parts here are worth £70. And again, you can just take a little bit of a logical approach there. Dividing that by 2 tells you the value of each part, and then you can stick your 35 in each of these piles and start to work it out that way. But I'm just going to do it via the numbers. Look, we're just going to divide this by 2, and that tells us that 1 part, which is what we're looking for every time, equals £35. And then from there you can take exactly the same approach we can do for Tom. He's got 5 lots of that, so 5 times 35. There we are, and 5 times 35 is 175. So Tom's getting £175. And Amy, who is getting 3 of those, is going to get 3 lots of 35. There we go, and 3 times 35 is £105. And again, you can add those 2 together to get their total. This one actually doesn't ask for their total, it says how much do they each receive. But if it did, if it said work out the total that they both get, you could actually add those together, look, and we've got 280 as the total. So this question doesn't ask for that, but just thinking about what we could be asked. So we've got Tom gets 175, Amy gets 105, and if it asks for it, we know that they both share £280 between them. Okay, so this is following on from what we've just done. It's basically the same as what we've just done. It's just a few more words and a sort of all wrapped up in a problem that looks more complicated than it actually is. It says Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam stamps is 3 to 7. Then it says Tom buys some stamps from Adam, and then they have a new ratio. Tom to Adam is now 3 to 5. How many stamps does Tom buy from Adam? Now there's no extra stamps getting added in at any point. We're always having 240. If extra stamps were being added in, this problem does get a lot more complicated, but this type of problem here, look, there's only 240 and they're just sort of interchanging some between them. So if we have our first scenario, look, scenario number 1, we've got 240 stamps and we've got Tom to Adam in the ratio 3 to 7. Now obviously that's 240 stamps shared between them, so the total amount of parts there is 10. So we've got 10 parts equaling 240 stamps. So if we divide that by 10, we get 1 part equals 24 stamps. So if we actually multiply both these numbers, look, Tom and Adam, Tom gets 3 times the 24 and Adam has 7 times the 24. So if we work both of those out, 3 times 24 is 72. And Adam has 7 times the 24, which comes out as 168. There we go. So that's how many stamps they start with, but we've now got scenario number 2, or the second part of this scenario, where Tom and Adam now have stamps in a different ratio. So now it's in the ratio 3 to 5. So now we know it's in the ratio 3 to 5, we can go about splitting these 240 stamps up between them. So we've got 3 to 5, and that is a total of 8 parts. So we've got 8 parts that now equal 240 again. So again, we can divide that by 8, and 240 divided by 8 gives us a total of 30. So this time, 1 part in this ratio is equal to 30 stamps. So if we have a look, I'm just going to do this in a different colour. We've now got Tom, who's getting the 3 parts, gets 3 times 30, which is going to equal 90, and Adam is going to have 5 of them. So Adam gets 5 times 30, and he gets 150. Right, there we go. So obviously we're looking at, let's have a look at what the question said again. How many stamps does Tom buy from Adam? Well, Tom started with 72, now he has 90. So we can obviously work out the difference there. If we want to show our working out, we can do the 90 stamps that he now has, take away the 72 that he started with, and that leaves us with a total of 18 stamps that he must have bought there. So 18 stamps would be our final answer. And obviously we could have taken that from Adam as well. We could obviously look at the fact that Adam, who's here, started with 168 and then dropped down to 150, which is a loss of 18 stamps as well. So you could look at that in both different ways, but there we go, there's a difference of 18. Okay, so again, there's nothing more complicated in this question. It's just there's a little bit of different wording going on. So it says Maria, Dylan and Kate share £3,000. The ratio of the amount that Maria gets to the amount that Dylan gets is in the ratio 5:4. And Kate gets 1.5 times the amount that Dylan gets. Work out the amount of money that Dylan gets. So we want to have a look, how are we actually going to create this ratio? Because at the moment we've got Maria, we've got Dylan and we've got Kate, but it only tells us the ratio, and that's, so let's just highlight that, Dylan and Maria, or Maria and Dylan, 5:4. So we've got 5:4 for Maria and Dylan, but we don't know how much Kate gets in terms of parts of the ratio. But it does then say Kate gets 1.5 times the amount that Dylan gets. So Dylan gets 4 parts, so if we times that by 1.5, that actually gives us a value of 6. So Kate is getting 6 parts. Remembering multiplying by 1.5, if you don't have a calculator, just adds an extra half on. Half of 4 is 2, add it on gives us 6. So now that we've multiplied that by 1.5, the rest of the question's nice and easy. Because all we're going to do now is split that £3,000 in the question in the ratio 5:4 to 6. So if I get rid of this little bit of working out, this times 1.5, let's have a look. In total, that ratio adds up to 15 parts, and now we know that those 15 parts equal the £3,000. So we can find the value of 1 part again by dividing by 15, and 3,000 divided by 15 gives us a value of 200. There we go. So they all get 200. So we can go about timesing them all by 200. We're actually only concerned about Dylan in this particular question, and Dylan gets these 4 parts here. So we can just answer that straight away. Dylan's 4 parts, each one of them's 200 quid. So 4 times 200 gives us £800 for Dylan. There we go, and there is our final answer. And again, you could go about obviously finding out the amount that they all get. We could do Maria times 200, which is 1,000, and Kate's times 200, which is 1,200. And you could even add them all together then and show that there's £3,000 there. But that's how we'd approach a slightly different question here. We've got to think about creating the ratio slightly ourselves. Okay, so this is where we're going to apply some of our 3-part ratios onto some further problems. We're going to look at sharing in a ratio as well, which again is something I discussed in the previous video, which is part 1 linked in the description. So obviously check that one out if you haven't already, but we're going to have a look at actually applying these combined ratios when we've got some further problems to actually analyse here. So it says Anna, Beth and Charlotte share £138. The amount Anna and Beth get is in the ratio 4:5, and the amount Beth and Charlotte get is in the ratio 2:1. How much does Anna get? Okay, so we've got 3 people, we've got 2 separate ratios, so this is our little hint that we're going to make this 3-part ratio. So we're going to make that to start with, and then we'll have a look at actually answering the question. So we've got A to B to C, and at the moment we've got Anna and Beth sharing in the ratio 4:5, and Beth and Charlotte sharing in the ratio 2:1. There we go, so we can line that all up just like before. So let's make that 10 in the middle. So we'll times the top one by 2 and the bottom one by 5, and that's going to give us 8 and 10 on our top ratio and 10 and 5 on our bottom ratio. And there we go, there's our 3-part ratio done. Now we can actually have a look at the question, because it says that they share £138. How much does Anna get? So all we're doing is we're sharing in a ratio just like we've done before. So we just have a look at all these 3 parts, which is, you know, they're all sharing it. It doesn't say that there's a difference between them. It doesn't say that one of them's getting 138. So it's all of them there. So if we add those all together, 8 plus 10 plus 5 is 23. So we've got 23 parts that it says is equal to £138. And just like before, when we looked at ratios, we're looking at the value of 1 part. So to get the value of 1 part, we need to divide both sides here by 23. So 138 divided by 23 gives us the value of 6. So 1 part is equal to £6. Now we don't need to go ahead and find out how much everyone gets, because we only really care about what Anna gets there. So Anna, in our new ratio that we're using, is the 8. So Anna's getting these 8 parts, and 8 times £6 gives us our value for Anna, and 8 times 6 is £48. So Anna gets £48, and that is our final answer there. Now this says, in this question, E, F, G, H and A, B, C, D are mathematically similar. Just to talk about that very quickly, E, F, G, H goes from E to F to G to H around this shape and forms a shape on the left. So it's just a way of describing that shape there on the left, likewise with the ABCD. And it says they're mathematically similar, and it wants us to calculate some lengths. So we're going to find the length BC, and we're also going to find the length FE. Now BC is over here, B to C, and the other one there, F to E, is this one over here, this little one. Okay, so they're lengths we're going to be actually finding, but let's just talk about what mathematically similar means at the moment. Now that word there, mathematically similar, means that one is an enlargement of the other. So they're exactly the same shape, only that one has been enlarged, so the angles are the same on the inside, but the side lengths are all bigger by a certain scale factor, and that's the important word there, scale factor. When there's an enlargement of a shape, we need to find the scale factor between them. So in order to find the scale factor, we have to identify some common lengths on these two shapes. Now we've been given lots of lengths. We've got the 8 centimetres on the left there, the 7.5 on the right, and then we've got these two lengths down the bottom. Now those two lengths down the bottom there are matched between the two shapes. So in order to find the scale factor between the two, I'm just going to look at those two, the 6 and the 9. So in order to find that, I'm just going to take the big length from the big shape and I'm going to divide it by the little length there on the smaller shape. So the sum that I'm going to do to find the scale factor is 9, and I'm going to divide it by 6. And doing that on the calculator, 9 divided by 6 gives us 1.5, and that is the scale factor between the two, and that's absolutely key that we find that scale factor. Now if we didn't have a calculator, we might just have to take a slightly different approach, because it could be a non-calculator question, in which case what I would do is I'd look at this fraction here, 9 over 6, and I'd simplify it. Now the top and the bottom divide by 3, so that would give me 3 over 2, which can then be converted into a mixed number, or hopefully you know that half of 3 is 1.5, or you could write it as 1 and 1/2. Okay, either way, we've got a method there for thinking about the scale factor if we do or don't have a calculator. Sometimes there'll be quite nasty decimals and there'll be quite clearly calculator questions, but this could potentially be a non-calculator question here where you just have to simplify the fraction. So a couple of things to be thinking about there. Now when it comes to finding the length, we're either going to divide or times by that scale factor. Now let's do the first one to start with, the length of BC. Now that length BC that I've highlighted there in yellow is the same as this 8 centimetre length right here. So we're going from the smaller shape up to the bigger shape. And think logically, if we were to divide by 1.5, we'd get a smaller number. And if I work that out on my calculator, 8 divided by 1.5 gives me 5.3 recurring. So we know that that's not going to be the way that we're going to do this. Now what we're going to do, when we're going from the smaller to the bigger shape, we're going to just multiply by that scale factor, so times it by 1.5. And again, if this is a calculator question, nice and easy, type it in, we get 12 centimetres. If not, you may just have to multiply by that scale factor. Now 1.5 is quite a common one, and if you think logically about what that means, it times it by 1 and the additional half, so actually it just adds half back on. Half of 8 is 4, and if you add that on to 8, you get the 12 there. So there's just ways that you can do. Obviously you can do your multiplying decimals, so 8 times 1.5 if you didn't have a calculator. Moving on to the other one, we've also got to find the length FE, and that's matched up with this length here, 7.5. So to get from 7.5 down to the smaller length, this is where we are going to divide by the scale factor. So on your calculator, we're going to type in 7.5 divided by 1.5, being careful not to do it the other way around. Don't do 1.5 divided by 7.5, otherwise we're definitely going to get a very, very small length there. But 7.5 divided by 1.5 gives us the answer 5. So 5 centimetres would be the length of F to E there. Okay, so two different things that we can do. We can times or divide by the scale factor. We just need to remember, take the big length, divide it by the little length to get our scale factor, which we've got up here as 1.5, and then times or divide depending on whether we're going to the bigger length or down to the smaller length. Now for the majority of these questions, I am going to be using a calculator method, although there are some types of speed distance time questions where we may not need a calculator, and some of these we might not actually need one, so I'll have a look at thinking about that throughout the video, whether we actually need a calculator or not. But for this particular question, let's start having a look. So it says the distance from, I'm going to refer to these places as just their starting letters, from C to D is 45 miles. There we go, so that's the first part of this journey. Then it says from D to E is 20 miles. It says Colin drives from C to D, and then he drives from D to E. Colin drives from C to D at an average speed of 30, and then he drives from D to E at an average speed of 40, and we're looking at miles per hour in this question. Work out Colin's average speed for the whole journey from C to E. Now what I want to do is I want to organise all this information. And if you've seen my video on density, looking at mixture problems, I'm going to organise this in a very similar way. Now what I did in that question is I drew a two-way table. I'm going to do the same process for this one. Now on the left of this two-way table, rather than mass density volume like we had in that one, we're going to have speed, distance and time, and we need to know our speed, distance, time formula. Now speed is distance over time, and for those of you that like formula triangles, it's nice and quick for this question just to use a formula triangle, and we have speed, distance, time. Obviously not forgetting though that you do need to be able to rearrange that formula, obviously for your algebraic sort of methods with rearranging formulas as well. But speed is distance over time, and then obviously distance is speed times time, and time is distance over speed. So I talked about it in that video, but obviously when you use a formula triangle, all you have to do is cross off the one you're looking for. So speed, if we cross that out, and you get there distance divided by time. And likewise with the top, look, you cross off distance, and you have speed times time. So it's just a little quick reminder on how to use the formula triangle there. But now let's have a look at constructing the top of this table. So we've got from C to D, which is the first part of our journey. I'm just going to label that as C to D. Then we have D to E. There we go. And we also have our total journey. So let's just call that the total. Again, you can label these whatever you like. Okay, it's purely a way of categorizing and tidying up this information. So there's no set method for actually doing this. Now, if I just obviously draw in all my grids now, and let's just start filling some of these things in. Now it says work out Colin's average speed for the whole journey. So we're looking for this box here, the average speed for the whole journey. So that's our little goal there to get to that box. Now let's fill in what we've actually got. So we have from C to D was 45 miles. That's a distance, so 45. We've got from D to E is 20 miles, again that's a distance. And then later on we've got the speed from C to D is 30, so that'll be 30, and the speed from D to E is 40, so we can fill that in as well. Now we've not been given any more information, but there is one box that we can work out, and that is obviously the total distance there. If the distance on the first part is 45, the second part is 20, the overall distance is 65. Obviously just remembering that speeds cannot be blended together. If I go 30 part of the way, 40 another part of the way, that doesn't combine to make 70. I haven't driven 70 miles an hour at any point, so we don't just add those together, but we can do with distances and we can do with times, thinking about the logic of an actual journey here. Okay, so the average speed is going to be somewhere in between 30 and 40. And unfortunately, because the distances are not equal here, we can't think about doing some sort of average there because it's in a different proportion for each part of this journey. But what we can do is work out these times now, so I can go about actually working these times out. So think into our formula triangle. If I cross off the T at the top there, it's distance divided by speed. So I can go about working that out then. So distance there is 45, and we're going to divide that by the speed, which is 30, and 45 divided by 30, and I'm just going to do this one on the calculator, gets us 1.5 straight away on the calculator. So 1.5, and it's miles per hour, so that's 1.5 hours. Now the next one to the right of that, we've got a distance of 20 and a speed of 40, so I can do 20 divided by 40, and that gives me a half, or 0.5. There we go. And that can then be added together, look, because if the first part of our journey was 1.5 hours, the next one was 0.5, that's a total of 2 hours for the whole journey there. Now finishing that off, speed equals distance divided by time, so 65 divided by 2 there to finish that off. 65 divided by 2 is 32.5. And obviously this question is in miles per hour, so we just put miles per hour. There we go, and that finishes that question off. So obviously just looking at categorizing all these pieces, having a look at what journeys you have, and just writing down whether you have a speed, a distance, or a time for each one of those journeys, and then just going about filling in those missing pieces. All you need to remember is that obviously distances can be added together, times can be added together, but the speeds cannot, and we are going to have to figure out the distance and the time in that final journey there to actually go about working out that speed. So this question says Zara mixes 150 grams of metal A and 150 grams of metal B to make 300 grams of an alloy. And it says metal A has a density of 19.3, metal B has a density of 8.9, 9, work out the density of the alloy. So an alloy is just a mixture of metals, but ultimately we're mixing two things together and we're creating this new metal here, which is called an alloy when there's a mixture of metals. So we've got the density of the two metals and we have two masses up there of 150 grams. So throughout this topic we are going to be using the density formula, and don't forget the density formula, okay, a little trick for you here, is given to you in the units. You've got the units there, look, grams over centimetre cubed. Grams is a mass, centimetre cubed is a volume, it's mass over volume. So our formula for density is density equals mass over volume. There we go. And for the purpose of this video, I am not going to be rearranging the formula. I'm just going to use a formula triangle. It's just nice and quick because we're going to be using this formula quite a lot in lots of different ways. So I'm just going to use a little formula triangle. So that's density. That's not a D. There we go. Density equals mass over volume. I think I was writing my speed, distance, time one there when I wrote that. Right, so we can put it into a little formula triangle, and we're just going to use this throughout the video. Hopefully you're already well aware of how to use it. If you're not, essentially, if we want to find density, we cross out density, and it's mass over volume. If we want to find the mass at any point, we cross off the mass, and it's density times volume. And if we want to find the volume at any point, we cross the volume off, and it's mass divided by density. So there you go, there's a quick little 30-second on how to actually use this formula triangle, but you should be aware of how to rearrange the formula anyway, but it's just a little bit quicker for us. So when we've got this type of question here, there's a lot of information, and basically what we want to do is we want to remove all the information from the question and just tidy it all up and have a look and see what pieces we've got for which metals and which total this combined mixture. And I'm going to do that in a very specific way, and this is just my way of doing it, but I like to put it into a two-way table. So all I'm going to do is I'm going to draw a little two-way table, obviously a little bit different to a normal two-way table because down the side I'm going to have density, mass and volume. And along the top I'm going to have my three items. So I've got metal A, I've got metal B, and then I've got my alloy, which is the mixture of the two. I'll just label that as alloy. Right, so having a look at the question, and let's see which information we've got so far. Let's get rid of that. Right, so we've got 150 grams of metal A, so that is a mass, so that's going to be 150 in my mass of A. We've got 150 grams of metal B, again that's another mass. And we know that that's a total of 300, and even if it didn't tell us that in the question, which it does, we can add those together. Okay, masses can always be added together, and so can volumes. It's just the density part we're going to have to discuss. So it says metal A has a density, and let's swap colours here. Metal A has a density of 19.3. So in density we can put 19.3, and metal B has a density of 8.9. There we go. So unfortunately we can't add those together. Okay, thinking about density, I always like to think about a squash scenario. If you have like an orange concentrate and a water, if you mix them together, the density of that liquid, the sort of cloudiness of the drink, is somewhere in between the concentrate and the water. Okay, and the more squash you put in, or the more concentrate you put in, the darker that liquid gets and the less opaque it is and less see-through it is. Okay, so what we're going to have a look at is how we find the density of this here, because we can't just add them together or anything like that, even though we can add together these masses and we can ultimately add together the volumes. In order to get the density of the alloy, remembering our formula over here, density is mass over volume, we are going to need the mass of that alloy, which we have. We've got that it's 300 grams. I don't know why I swapped to that, there we go. We've got that it's 300 grams, just there, but we are missing the mass, so we need this, we're missing the volume, so we need to find out what that number is just there, and we can get that by finding the volume of the other two. Now when it comes to these types of questions, this is quite an interesting one because there is the same mass of both. Okay, so you might be thinking we can try and find an average at this point, but the volumes are not necessarily going to be the same, so we need to find out what those volumes are. So coming over to our formula, if we cross off volume, it's mass divided by density. So on both these steps I'm just going to do the mass, okay, which I've got here, 150. I'm going to divide it by 19.3. So I'm just going to do that to the side. This one here, we've got 150 divided by 19.3. There we go, and let's work that out. 150 divided by 19.3 on the calculator gives us quite a nasty decimal. Normally it will say how to round it. This particular question doesn't, so I'm just going to round it to 2 decimal places. Although if a question doesn't say how to round it, you definitely don't round it, but for the purpose of this I'm just going to round it to 2 decimal places. So there we go, 7.77. and if you're wondering what units goes with that, always just have a look in the question. It's always given to you in the densities there. So the density said it's grams per centimetre cubed, so that would be 7.77 centimetre cubed. I'm going to do the same again for the other volume. So for this column B here, I'm going to do 150, divide it by 8.9, and that gives me 16.85 to 2 decimal places. So 16.85. There we go. And now we've got those two volumes, we can add those two together. So for that final volume of the alloy, we're just going to do 16.85 add 7.77, and that gives us a total there of 24.62. So 24.62. And on these types of questions, obviously I'm minimising the amount of working out that I show, but do make sure you show this working out here for both of them. Even though it's all quite nice and tidy in a table, do show that working out to the side, okay, because those sorts of things are worth marks. Now for the final part of this question, we can now actually get the density. We've got the mass, we've got the volume, so all I need to do is mass divided by volume. So my final bit of working out here is going to be the mass, which is 300, divided by the volume there, which is 24.62 centimetres cubed. So 300 divided by 24.62 gives me a final answer of 12.19, if I round it to 2 decimal places, grams per centimetre cubed. Now the decimal does come out as a lot longer than that, it's 12.185,21527, so I would write down the full number there and keep all the numbers if it didn't say how to round it, but these questions that we're going to look at now are going to tell us how to round it, but we're just not really worried about that for the first question. So there's our final answer, 12.19, and obviously just take note of the fact that it is somewhere in between the 19.3 and the 8.9, okay? It's sort of not halfway in between, but it's somewhere in between the two, okay? So this first one says, and to be honest, before we start, we need to just have a look at this little symbol here. This just means the universal set. It just means all the numbers that are going to go inside this Venn diagram somewhere in there. And in that it says all the odd numbers less than 30. So it might just give you the list of numbers. If it doesn't, it's probably best just to write them all out. And there's quite a lot of odd numbers between 1 and 30, less than 30. So I'm not going to write them all out, but you could just go ahead and write them all out. 1, 3, in fact, let's just write them out. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and the rest. Now these are all the numbers that are going to go in the Venn diagram, and they're only going to go in there once. Okay, so there's not going to be any repeats of these numbers, but they are all going to go in the Venn diagram. Now it says set A has got these numbers and set B has got these numbers. Now if it doesn't label the circles in the Venn diagram, just label them yourself. So we'll call this A and this one B. So having a look, now the first thing we want to identify is what can go in the crossover, the intersection there. So if we have a look in A and B, there is a 5 in both, so let's cross off the 5 and let's put that into the Venn diagram. And I'm also going to cross that off my main list up here as well, cross that off, so we're not going to put it in twice. Let's have a look, there's also 15 in both, so let's cross that off and we'll put that in the middle as well, and then we'll cross that off the main list. So these are all the numbers that we've got left to put in a Venn diagram. There's none that are in A and B anymore, so all those numbers are in set A. I'm just going to put them in the A circle, so 9, 17, 21 and 29. We'll cross those all off and cross them off the main list, so 9, 17, 21 and 29. There we go, they're gone. And then 25 in B as well, so we'll put that one in there. Again, crossing it off both lists. So in terms of the numbers we have left, we've got the 1, we've got the 3, and I'm not going to circle them all, I'm just going to start putting them in because the others are crossed off. We've got 7, 11, 13, 19, 23 and 27. There we go, and that is our completed Venn diagram. Now we could be asked any sort of question on probability here, but I've put a little selection in down the bottom. It says a number is chosen at random, find the probability that is in set, and then we've got 3 questions to have a look at. So we've got 2 symbols that we need to know here. We've got the U, which is the union. And there we go, the union, we'll talk about that in a sec. And we've got the N, which is the intersection. There we go. And these little symbols can be replaced with some words if it helps. So the U for union, I replace with the word or, and the N for the intersection, I replace with the word and. And I quite like replacing it with the word and because the middle letter in and is N, so I always tend to remember that the intersection there, the N is and. So let's have a look. The first one is U, so we've got A or B. So the numbers that are in A or B. and it is a probability, so we'll talk about writing it as a probability in a sec. But if we have a look at the numbers that are in A or B, well, we've got the 9, the 17, the 21, the 29, which is in A, we've got the 25, which is in B, and then we've also got the 5 and the 15, which is in A and B. So just because that's in both doesn't mean it's not in A or B. So in fact, finding the numbers that are in A or B is all of these numbers within the Venn diagram, okay? So they are all the numbers that are within the Venn diagram there. And if we count them up, there's 1, 2, 3, 4, 5, 6, 7 numbers there. I'm going to get rid of that highlighter there, but we've got 7 numbers. So let's write that down. We've got 7 numbers that are in A or B out of a total. And again, you can count them all from the Venn diagram or from that list that I did at the top, but all the odd numbers between 1 and 30. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. There you go. So it's 7 out of 15. So that word union, if you think about that as like the United Kingdom, the union is the collection of all the countries there, and it's the same for the Venn diagram. It's the collection of everything within that sort of that land there. If you kind of imagine it like a country, you've got the collection of all the numbers. So you've got 7 over 15, and that is the union of A and B. Now if we have a look at the next one, so B, we've got A and B, or the intersection of A and B, which again can be replaced with the word and. So the numbers that are in A and B, well, there are only those 2 numbers there that are in both A and B, the 5 and the 15. So that there is the intersection, the numbers that are in A and B, and if we write down a probability of that, that's 2 numbers out of, again, 15 numbers. There you go, so there's our 2 options there for the union or the intersection. I've also included this extra one here as well for C, which is A dash. Now if there's a dash with a letter, it means not in A. So all that little dash means is any of the numbers that are not in A. Now if you have a look at the numbers that are not in A, well, we've got the 25, which is in B, that's not in A. We've got all these numbers around the outside that are not in A, but none of the other numbers. So we've got the numbers which are just in A, the 9, the 17, the 21, the 29, and we've also got the numbers that are in A and B, the 5 and the 15, but they are also in A, so we can't have those ones. So we're just looking at the numbers that are in B and the numbers on the outside. So we've got 1 number in B, and 1, 2, 3, 4, 5, 6, 7, 8 numbers there in green around the outside. 8 plus 1 is 9, so there are 9 numbers that are not in A, and again that's out of 15, writing it as a probability. Okay, so this question says, in a bag there are red, blue, yellow and green counters. A counter is taken at random from the bag and the table shows the probability of getting each coloured counter. So we've got red, blue and yellow and we're missing green. Then it says later in the question, look, it says there are 45 green counters in the bag, work out the total number of counters in the bag. So if we have a look here, we just need to figure out what's missing. What's that probability of getting green to start with? Because it's slightly different. It's not saying how many times they're going to pick the counters out or something along those lines. It's actually given us an actual amount of counters allocated to that probability. So at the moment, if we add all of these up, we've got 0.3, 0.25 and 0.15. And they add up to 0.7 or 0.70. There we are, so we're missing 0.3, which again is 30%. There we go. So 30% of the counters are green. And it says down here there are 45 green counters. So this is actually telling us that 30% is actually equal to 45 counters. There we go, so that 30% there is 45 counters. And we need to find out the original amount of counters or the total amount of counters in the bag. And in order to do that, we need to turn that 30% back into 100%. So this is almost like a reverse percentage, because we need to break this down in order to turn it back into 100. We can't just multiply it by 2 or multiply it by 3. It's not going to get us to 100%. So if we go about breaking this down, always look, how can we get back to that 10%? And to get 30% back to 10%, we would have to divide that by 3. And that would tell us that 10% is equal to 15 counters when we divide that by 3. There we go, so 10% is 15 counters. And now we're able to turn that back into 100. And from 10% back to 100 is nice and easy because we just need 10 of those. So times it by 10. So that original 100% of the counters is 150. There we go. And there's our final answer. So a slightly different bit of wording there. It actually allocates the amount of counters to that certain percentage. So it's called a reverse percentage. obviously because it's not given us the 100%, it's given us part of it, and it's looking for us to go back or build it back to 100%. Now it says Josh gets the bus to and from school each day, and the probability that his bus is late to school is 0.14, and the probability that his bus is late home is 0.32. Work out the probability that exactly one bus is late. And we'll have a look at that language in a sec, exactly one bus is late. But let's just have a look at constructing our tree here. So we have one option here, and let's think about this as his journey to school. So let's just label that as to school. And it says it's either late or not late, and we're just going to put not late for that. So the probability that's late is 0.14. So if we take that away from 1, or think about it as a percentage of 100, so that's 14%, and 100% take away the 14% would leave us with 86% or 0.86. Obviously just take your time with that. These two branches here have to add up to 1, so always just double check that they do actually add up. And that's the journey to school. Now obviously two separate journeys there, and then we've got to think about the journey home. And again, it mentions that it's either going to be late, so I'll label that late, and not late. And again, I'm just going to quickly draw in the one below as well, because these are going to be replicated. They're going to be the same, the top and the bottom. So it says the probability is late home is 0.32. So we can put that in the late there, and we can put it on the late down here as well. And again, that's 32%, and 100 take away 32% would leave us with 68%, sorry. So that would be 0.68. There we go, and again just double check that they definitely add up to 1. Now this question said exactly one bus is late. So in this time, late at the top, that's not exactly 1, so we don't want that one. We've got late and then not late, that's exactly 1. We've got not late and late, that's exactly 1. And then we've got 2 here where they're both not late, so that's definitely not exactly 1. So we've got the two options there that we want. We've got the ones in the middle, and they're the two that we need to work out here. You've got to be careful with this one, because these two in the middle aren't going to be the same like they were in earlier questions. They are actually going to be different probabilities in the middle here, so don't just work out one and double it, always just work out both of them. So going up the late, we go through 0.14 and 0.68. So if we work that one out first, we've got, and let's see if we can do this to the side. So we've got 0.14 multiplied by 0.68, and that gives us a probability there, which I'm going to do on the calculator. 0.14 times 0.68 gives us a probability of that's a bit longer, let's have a look if we can fit it in, 0.0952. There we go, and that is our first probability, 0.0952. Let's have a look at our second one. So for the second one, obviously we could be not late and then late, and that's going to be, let's see if I can fit this in, 0.86 multiplied by the 0.32 there. And again on the calculator, 0.86 times 0.32 gives us a probability of 0.2752. 0.2752. There we go, and that's the probability of that route. Now obviously just like before, we've got two outcomes here. We've got late and then not late, or not late then late, so we need to add them both together. So if I do that up here, we've got 0.0952, and we need to add to that 0.2752. There we go, and if we add them together, 0.0952, I'm going to do it on the calculator, we get 0.3704. 0.3704, and there we go, there's our final answer combining those two probabilities. Okay, so slightly nastier in terms of the decimals there, but obviously you can see that the process is the same. It's all about just constructing that tree very carefully and making sure that you go through the appropriate routes. Obviously if you're happy to do this without a tree, you can do, but I would advise a lot of people obviously just prefer the visual method here, actually seeing the journey. Okay, so in this question there's some slightly different language. Now it says Cameron has a bag of counters, and in the bag there are 3 red and 4 blue. Cameron takes at random 2 counters from the bag. Work out the probability that both counters are the same colour. Okay, so I'm just going to highlight the key bits of information there again. Now obviously with this question, the language that's different is this line here where it says he takes 2 counters from the bag. Now if it doesn't explicitly say that he puts the counter back in the bag, then he doesn't, and we're going to assume that he doesn't, unless it explicitly says so that he puts that counter back in the bag. So for this question we're going to treat it in exactly the same way as the first one, and just be careful, because although it says he takes 2 counters from the bag, that doesn't mean he takes them out at the same time. He takes one, we're going to write that as our first part of our probability tree, and then he takes the second. So we're not going to be reducing our denominator by 2 or anything anything like that in this case. We're just going to treat it in exactly the same way as the first question. So for this part of the first part of the tree, we've got our first pick, and that is going to be red or blue. And again, there are 3 red and 4 blue, so that's 3 out of 3 plus 4 is 7, so 3 out of 7. And then blue is going to match that to make 4 out of 7 to make sure that denominator there adds up to 7. And obviously it does say this 4 blue, so that makes sense for us. Now have a look at the first part of the journey. If he takes out a red, which I'm going to do first, then we can work out the probability of red. So if he takes out a red, there's now only going to be 2 reds, and again you can draw your picture for this, and that'll be out of 6 now, so 2 out of 6. And don't feel the need to actually simplify that fraction or anything, we'll leave it as it is. So the probability of blue still is 4, but now it's out of 6 counters. So just matching that denominator, that numerator that we originally had for blue. And that's that first option there for our journey if we took out a red first. Now going down to the bottom, if we took out a blue first, let's have a look, and I always start with that colour first, so blue. If we took blue out first, that's going to reduce down to 3, and again that's going to be out of 6, and again no need to simplify any of these. And then red, the red numerator would stay the same. There was originally 3, no reds have been taken out this time, so that stays as 3, and again that's out of 6. And there's our tree constructed. Again, draw your little picture like I did in question 1 if you feel like you need to. Now this is the probability that he takes out the same colours. So the same colours, we can have red and then another red, and that's going to be 3/7 that we've gone through, multiplied by 2/6. There we go, and 3 times 2 is 6, and 6 times 7 is 42. So there we go, there's our first probability there for getting 2 reds. Obviously we can also have 2 blues, so we can have a blue then a blue, and that's going to be 4/7 multiplied by 3/6, and that gives us 12/42. And there we go, and there are only options there for getting the same colours. So just like before, we can add those together. So 6/42 multiplied by, add them together and then write multiply. So there we go, add 12/42, and that gives us 18/42. And again, no need to simplify that. That tells us there's 18 different ways out of a potential 42. So there's our final answer, 18/42. So this question says Rosie has 10 boxes of drawing pins. She counted the number of drawing pins in each box, and this table gives some information about her results. Now we can see in the table we've got the boxes with 29 drawing pins there. There was 2 of those. The boxes with 30 drawing pins, there were 5 of those, and so on. 31 where there were 2, and 32 drawing pins there was only 1. And it says work out the mean number of drawing pins in a box. Now we know hopefully when we're working out the mean, you add up the total of all the different boxes of drawing pins here, and we divide by how many boxes there are. And this question's nice, it actually tells us that there's 10 boxes, so we know that we just need to get the total and divide by 10. Now obviously this information is within a table, so we don't have our normal list, although we could actually imagine what we would do if we had a list. Now if we did have a list here, now 10's okay, but once we start getting to tables where there's 80, 100 things in the table, we won't want to do it in this particular way, but just so you have an understanding of how and why we do the process we do, we'll have a look at this first one. So we've got 2 boxes of drawing pins that have 29 in, so we'd have 2 29s, so 29 and 29. Then we've got 5 with 30 in, so 30, 30, 30. You can already see it's actually already a bit annoying having to write these all out. 30 and 30, there we go. We've got 2 with 31, and another 31, and we've got 1 with 32 in. So I could just give you this list here and say work out the mean, and what you do is you just add them all up and we would divide by 10. So with this particular table we could actually just take that approach, it'd be nice and easy to do so, but obviously as I said, as they get a bit trickier we're not really going to want to take that approach. But essentially we're going to have a look at what the totals of all the numbers are, and what we're going to do, obviously because they're categorised, what we're going to have a look at is we're going to look at the total of these 29s to start with. Now there's 2 of them, so 2 29s, we could add those together and we get a nice total there, and that is 58, that total. Then we would have a look at the 30s and we'll add all of those up. We've got 30, 60, 90 plus another 2, 120, 150. So the total of those is 150. The total of the 31s is 62, and the total of that 132 there is 32, and then we can add them all together as groups. Now what we're going to do is we're going to take that away from the list and have a look at it from the table. So we'll get rid of all of that, and we'll do it from the table here. So we've got 2 29s, now all we have to do is times the 29 by 2, and that gives us their total there. So 2 lots of 29, we've already said, is 58. Then we've got 5 lots of the 30s, and that was 150. We've got 2 lots of the 31, that's 62, and 1 lot of the 32, and that gives us 32 as the total there. Now throughout these questions they could be calculator, they could be non-calculator. I am just going to use a calculator. Well, I've got to be honest, I think this question is a good non-calculator question, but as long as you know the process. Obviously if it was a calculator question it would be quite nasty numbers, one that you wouldn't be expected to do without a calculator, but they could be non-calculator as well, and here's an example of one I think where this could be non-calculator. So let's have a look. Now we've got all these totals for each row, we can actually just add those all together. So 58 plus 150 plus 62 plus 32 gives us the overall total there of 302 for the total number of drawing pins in all these boxes. Now we already know we're going to divide by 10, as it says in the question up there that there's 10 boxes, but if we didn't actually have that piece of information we could find that because we've got the total frequency just here. And if we do 2 plus 5 plus 2 plus 1, we get a total of 10 boxes. So all we need to do to finish this question off to get our value of the mean is we're going to do 302, the total of all the drawing pins, and divide it by the 10 boxes. As you can see, that would obviously be why this might be a non-calculator question, because dividing by 10 is nice and easy. We just hop the decimal in and we get the answer 30.2 for our mean. So in terms of a process there, look, we times across, we get all the totals for each category, we add them all up and divide by how many things there are, and in this case the things is the 10 boxes, and we get that just by adding up the frequency column down here. Okay, so that word that I've mentioned, grouped frequency, refers to these categories here. So this question is about 40 friends and how long they took to get to work. So we've got a category there, and that means from 0 to 10 minutes, including the 10. Okay, obviously not including the 0 there, because no one's going to take 0 minutes. So it's anywhere between 0 and 10. And obviously that little symbol there, the equal to symbol, tells us it can actually be equal to the 10. The one below then, look, starts on 10, but obviously it's got that not equal to 10 there. So obviously anyone that's on 10 minutes exactly would go into the category above where it can be equal to 10. So that can't be equal to 10, but it's between 10 and 20, and again it can be equal to 20. And that sort of pattern there just follows all the way down the table. The next one 20 to 30, not including 20, but does include the 30. Okay, so that's what those little inequalities are, those little groups, and it's called grouped frequency, but these little things here are also called classes, or it's called a class. Okay, and think about that word class. If you're in a class at school, that refers to the group that you are in. So another word for group is a class, and we're going to refer back to that word later on in the video. So when it comes to this sort of question here, basically we don't know how many of these three people or where they're actually at in terms of their minutes. They could be 1 minute, 2 minute, 3 minute, any sort of subcategory of that. So they could be 4 minutes, 50 seconds. It could be anything within 0 to 10 minutes. So essentially we don't actually know the times within the group. Although we know that there are 3 people within that group, we don't know their exact times. So the question down here, look, in this final line, this says it's something different in the words. It says work out an estimate for the mean time taken. And we're working out an estimate because we obviously don't actually know their exact times. If we did know their exact times, we could calculate or work out the mean. But for this particular question, we're going to estimate the mean. So in terms of actually making an estimate, what we're going to do is we're going to make a guess for these people's times, obviously an educated guess. Between 0 and 10, the midpoint, or in the middle of that, is 5. So we're going to use 5 instead of any of these random numbers in between 0 and 10. So say, okay, 5's in the middle, so we'll use that. In between 10 and 20, that in the middle of that is 15, so we'll use 15 for that category. 25 between 20 and 30, 35 between 30 and 40, and 45 between 40 and 50. Now I've assumed there that you can spot those in your head. If you can't, let's have a look at this category, for example, 20 to 30, you could just add together 20 and 30. You could do 20 plus 30 and then halve your answer. And again, 20 plus 30 is 50, halve it is 25, and it gives you that midpoint. So if they are a little bit more complicated and you can't spot them in your head, there's a little trick for you just to find the midpoint, okay? And you can always use that to find the midpoint of 2 numbers as well. Now we just follow the same process. So now I've got my estimated midpoints, or my estimated times in the context of this question. I'm just going to times them all across like we did before, and the rest of the process is basically exactly the same. So 5 times 3 is 15, 8 times 15 is 120, 25 times 11, and I am doing these on the calculator, is 275, 9 times 35 gives us 315, and 45 times 9 gives us 405. Now there we go, there's the total of all our times for each category, and again we're just going to add those all together and get our overall total. So add 405 315 plus 275 plus 120 plus that 15 sitting on the top, and that gives us a total of 1,130, and that is our overall total there. Now again, this question did say there's 40 friends, but again, just double check and add that all together down the bottom here, and the total frequency there does add up to 40, so it's all okay. And again, we just finishing off the working out just like we did before. We've got our big total 1,130, and we're going to divide that by the 40 people and see what we get for our estimated mean. So dividing that by 40 on the calculator gives us a final value of 28.25. Obviously the context of this question is about minutes, so it's 28.25 minutes, but that is our final answer there. And again, just looking back at the table, 28.25 makes sense. It's somewhere in this middle category here, which is also the most popular. Okay, obviously there's 11 there, so that would make sense that the average or the mean would be within that category as well. So there we go, that's how to get an estimated mean from what we call a grouped frequency table. Don't be put off by that word grouped frequency, it just refers to these tables here where we have a class interval there and not actually just a number within that. Okay, so that is how you work out an estimated mean. Okay, so we just looked at this question previously. Okay, it was about Bob asked each of 40 friends how many minutes they took to go to work. The table shows some information about his results. Obviously we're going to look at these in separate parts, so we're going to start by finding the class interval that contains the median. Now again, that language there, class interval, just means the group, okay, this one here, that contains the median. The group, the interval, is just the language for for it being between 0 and 10. So the interval for that is between 0 and 10. So the class interval is the group between two numbers, so basically, if we turn that into sort of simpler words. So we're looking at the class interval that contains the median. Now the median, hopefully you already know, is the middle number. So what we're going to have a look at actually is how we get the middle number from a table. Now it says up here that there's 40 friends. Again, if it didn't, we know how to find that now. We can go down to the bottom and find that there's 40. Now when we're finding the median of anything, the statistical way of doing that is we add 1 and half it. If you think about a little bit of a logic here, if we have 5 people, let's just draw a little picture here. If we have 5 people standing in a row, oh dear, I've committed to drawing 5 people now. Right, here we go. Let's draw them as best as I can. Okay, 5 amazing little drawings there. And we want to find where the middle person is. Obviously, logically, we know that that middle person is this one right here, the third one along. But if you take 5 people and divide that by 2, you don't get 3, you get 2.5. So it doesn't actually find that middle person. So actually, the logic we have to take is before we halve it, okay, we have to add 1. So 5 plus 1, which is 6. Then we divide it by 2. 6 divided by 2 tells us that the middle person is the third, and that is correct. Look, 1, 2, 3, our middle person, 4, 5. So when we're finding the median, hopefully that is a nice little simple example as to why you add 1, but we have to add 1 first and then actually halve it to find out where our middle value is going to lie. So let's have a look. Now we've got 40 people, so 40 plus 1 is 41, and then we're going to halve that. So 41 divided by 2 is 20.5. So we're going to try and find where the 20.5th number is, and that seems a little bit weird. Sometimes it's a bit easier just to halve 40, but mathematically that's not actually correct, and it's not going to be a good way to learn this as it progresses onto other topics when we start to look at things like box plots and stuff like that, and stem and leaf diagrams and all that sort of stuff. So let's have a look, the 20.5th number. Now what we're going to do is we're going to do something called a cumulative frequency here. So what I mean by that is we're going to do a running total down the table. So as it stands on this first column, look, we've got a total of 3. Once we add in this extra 8 here, well, 3 plus 8 gives us 11 people in total now, so we've not quite got to that 20.5th person. Not that we can have half a person, but just in terms of our median, we've not got to that 20.5th number yet. Once we add the 11 in, that gets us to 22, and that has just gone beyond the 20.5th number. So there we go, that 20.5th person is somewhere within that little category there. Okay, obviously not in the category above because we're only at 11 people by then, but as we progress down the list, that 20.5th sort of person there is going to be in that third category. So that leaves us with a median in this category here. So our median class interval is going to be that 20 to 30 right there. And when we write down our answer for that, so for part A, we would literally just write down exactly what is written right there. So 20 with our inequality to 30. And there we go, there's our median class interval. Okay, so all we do is we get our total, add 1, halve it, and then count down our list using cumulative frequency to figure out where that person actually is. And we just wait till we've gone just beyond it, and that's the category that they're in. The next part here, the modal class interval, is a lot easier. Write down the modal class interval. Now that word modal just stands for the mode. There we go. But because it's referring to a class interval, again, just one of these groups, we use the word modal. Okay, so write down the modal class interval. Now that's nice and easy to find. All we have to do is look down our frequency and see which one is the most popular. Okay, the mode is the most frequent. Okay, if we write that down, most frequent, or the one that's the most popular. Okay, I tend to use that word popular rather than frequent, but that is the mathematical language there, the most frequent. And if we look down our table, we've got 3, 8, 11, 9 and 9. 11 there is the most frequent, okay, the most common. So our modal class interval is also that particular category there, which is ends up being the same as our median in this particular question. So our part B there, we'd write down the same thing. We'd say 20 to 30. And that is our modal class interval, our most frequent, okay? And this same logic applies when it's a non-grouped frequency table. Obviously, when it's non-grouped frequency, it won't say write down the modal class interval or the median class interval. It would just say write down the median or write down the mode, okay? Okay, but obviously it's a little bit trickier when you've got to write down the actual interval, but the process is exactly the same on the other table as well. So we're only going to practice on these particular tables because they're a little bit trickier, just in terms of what you have to write down. But honestly, both the questions are exactly the same here, but I've just chosen to actually go with these ones as they're a little bit more popular when you're asking to look for the median or look for the mode. Okay, so that is how you actually go about doing that. In terms of the actual range, the range is quite nice and easy. I'm not going to actually get you to have a go at these because they're so nice and simple. Obviously, when you're looking at the range, you just do the biggest, take away the smallest, and our biggest time, take away our smallest time. Obviously, if there were numbers in here, then we could just do the biggest one down here, take away the smallest one up here. But as they are classes or groups, we can't do that, so we estimate the range. We would do the midpoint, the 45 midpoint, take away the 5 midpoint up here. So to estimate the range, that is an estimated range here, we'd do 45, take away 5, and our range would be 40. Really nice and simple to work out the range, but we're going to focus on median and mode. But that is how you work out all the averages from one of these tables. So it says here there are 10 boys and 20 girls in a class, and the class has a test. It says the mean mark for all the class is 60, and the mean mark for the girls is 54. Work out the mean for the boys. So when it comes to a question like this, obviously we know, or hopefully we know, that when we're normally working at a mean, we get the total, we divide by how many people there are or how many things there are, and we get our mean. Okay, so we do the total and we divide by the amount, okay, for whatever it is. There we are, on its most basic sense there with the mean. You do the total divided by the amount. Well, in this question here, obviously it doesn't actually give us the total. It tells us what the mean is, it tells us the amount, it tells us that there are 10 boys and 20 girls, but it doesn't actually tell us the total. So what we're going to do is we're going to go backwards to work out some of these totals, okay? So we're going to think about this in reverse. All right, and that is how you get the mean there, the total divided by the amount. Okay, so if we link some of these things up, then it says that there are 10 boys. It doesn't give us the mean for the boys, so that's no good so far. So that first piece of information that we are actually given in terms of the mean, it says the mean mark for the whole class is 60. Well, if we were going to work out the mean for the whole class, we'd get their total, let's call that x. We divide it by the amount, and in this case the whole class, well, there's 10 boys and 20 girls, so we would divide it by 30, and it would give us this mean here, which it says is 60. So in other words, we're looking for a number that divides by 30 that gives us the answer 60, and we can just do that in reverse. We can just do 60 times 30. So actually all we're going to do in these questions is we're going to link the mean that we're given with the amount that is appropriate for that mean. So I'm going to get rid of this little bit of algebra that I've drawn here, but obviously you could think of it in terms of an equation, but this is the sort of concept that we're going to run throughout this question, and hopefully once you actually get your head around this and why we multiply instead of divide, obviously we are doing a reverse. This question obviously becomes a lot easier then. Okay, so obviously thinking about this topic's actual name, it's called a reverse mean. Normally when you work out the mean you do a divide, and obviously then the opposite or the reverse of dividing is multiplying, and in these questions we're going to be multiplying rather than dividing to go backwards. So let me get rid of that. So let's have a look. So obviously we've been given that the mean for the whole class is 60, and we've just established that there's 30 students or 30 people in the whole class. So we're going to do 60 times by those 30 students, and that's going to tell us their total. So 6 times 3 is 18, add on the 2 noughts, that's 1,800, and that is the total for the whole class. And it's usually worth just labelling these, particularly if you haven't quite got your head around it. Let's just label that total for class. There we go. Right, so the next bit of information then, we've also been told that the mean mark for the girls is 54. Now, in terms of the question, look, there are 20 girls. So if there's 20 girls and their mean is 54, we'll take their mean, 54, times it back by that 20 to find out what their total was. So 54 times 20, there we go, and that gives us 1,080. And there we go, there is the total for the girls. And let's just label that again. Total for girls. Right, so just thinking logically about the information that we've got here, we've got a class of boys and girls. It says the total for the class is 1,800, the total for the girls is 1,080. So logically we can work out now the total for the boys, we can subtract those away from each other. So 1,800, take away 1,080, and let's write that down. There we go, take away 1,080, leaves us with 720. There we go, and that's the total for the boys. Let's label that up, total for boys. And now we can go about answering the question, because now we know the total for the boys, we can actually think about working out their mean, and that's what the question wanted. It said work out the mean for the boys. So we've got the total for the boys is 720, and in total up here we were given in the question, let's highlight it in the same colour, there are 10 boys. So to work out the mean, just like normal, we would just finish this off by saying the total for the boys is 720. I'm going to divide that by how many boys there are, which is 10, and that gives us a mean of 72. There we go, and there's our final answer. I'm just thinking about what we did there, just working backwards through the question, multiplying the means by the amount to get the totals, and then using a bit of logic there to find out therefore what the total for the boys must have been, and then just working out the mean as normal. Okay, so this one's a little bit more interesting because the scale's a little bit different on this one, but essentially we're going to be doing the same thing, although it does say in the final line here, it says draw a frequency polygon to show this information and write down the modal class interval. Okay, so we're going to have a look at that word there, that modal class interval, in a sec, but let's actually go about drawing this frequency polygon. So in between 10 and 14 for this first class, in between 10 and 14 is 12, and then we have 16, 20, 24, and 28. And again, just plotting these, but you do have to watch out here, because if you have a look at the y-axis, it goes from 0 to 5, and that is 10 squares. And if 10 squares go from 0 to 5, that means every square is 1/2. So I'm just going to have to be very careful here, because it's 2 squares for every 1. So for the first one, 12, which is 2 squares after the 10 down the bottom here, 12 is here, and it wants us to go up to 2, so that's going to be 4 squares up, which is there. The next one, 16, goes up to 5, that's easy enough because 5 is labelled for us, so that's there. We've got 20 going up to 12, 12 is going to be 4 squares above 10, there we go, there's 12. 24 goes up to 8, so that is going to be there for 24, and for the final one, 28, that goes up to 3, which is 6 squares up, and that's going to be there. This is quite a little compact one here in the way that it's spread out across the x-axis there, but joining it up in exactly the same way, first to second, second to third, third to fourth, and fourth down to fifth, again using a ruler and a pencil. Now for the final part of the question here, it does say write down the modal class interval. Now the language in there, you've got that word modal, which is just another word for the mode, so the mode being the most frequent, but it's saying the most frequent class. And again, I referred to these here, these are the classes on the left there, those categories, those groups. Class is just another word for those. So it's asking us which is the most frequent group, or the most frequent class, the most frequent interval there. And the most frequent is this one here with the 12 in, and that refers to this class here, which is 18 to 22. So all we're going to do, if we're writing down the modal class interval, is to write down exactly what's in the box there, which is 18 to 22, getting the symbols obviously as they're written in the box, and that is our modal class interval, 18 to 22. Now it says Hannah is planning a day trip for 195 students, and she has a sample of 30 where they want to go, and each student chooses a place. It says the table here shows the information about her results, so we can see that there's people that want to go to the theme park, the theatre, the sports centre and the seaside. And it says work out how many of the 195 students you think will want to go to the theme park. Okay, so we're just looking at the theme park here, which is just here, and it says state any assumption you make and explain how this may affect your answer. Okay, and we'll have a look at that a bit when we finish. First of all, let's try and work this out. Now there's a couple of different ways that we can do this. I'm going to discuss the non-calculator method to start with, as this is quite a nice non-calculator question. Now it obviously says that she takes a sample of 30 students. If it doesn't say that, we can get that from the total down here, and we get a total of 30. Now in terms of the students that want to go to the theme park out of the sample, well, there are 10 students in the sample, so that is 10 out of 30 students. Okay, so that's 10 out of 30 that want to go to the theme park. And if we simplify that fraction, that simplifies down to 1/3, okay, dividing the top and bottom by 10 there. So what we can say is that we know 1/3 of the students, based on the sample, are going to want to go to the theme park. So if she's going to ask 195 students, then we just need to work out 1/3 of the 195 students that she's planning for. So we could work that out. We could do 1/3 of 195, and obviously if we're doing this without a calculator, we're going to want to use a bit of bus stop here. So 195 divided by 3, 3 goes into 19 6 times up to 18, remainder 1, and then it goes into 15 5 times. There we go. So our answer here would be 65 students, okay, that we were expecting to want to go to the theme park there. So that's obviously a little non-calculator method. It works quite nicely for this question here, but they're not all going to be non-calculator questions, so we could have to do this in a calculator way as well. Now if we've got 30 people in the sample, essentially we want to figure out how do we get that 30 to represent 195 students in a way. So how do we get from 30 to 195? Okay, we've got 195 that we want to go. So if we figure out how we can turn this and scale it up to 195, we can figure out how many 30s go into 195. So if I can do 195, I could divide it by 30. Let's do this on the calculator. And that equals 6.5. Let's just write that down. There we go. So essentially all I need to do is multiply all of these by 6.5, and that would get me to the appropriate amount. Now it only wants the theme park, but I could go and multiply them all, and 10 times 6.5 is equal to 65. There we go. So we can find it that way as well. Okay, just figuring out how many times that sample has to fit into the total amount. Sometimes that's not going to be very nice, as you might have spotted the one below. If I do 5 times 6.5, that would get me 32.5 people, and obviously we can't take 32.5 people, so you'd have to end up rounding some of these and sort of doing that appropriately, and it doesn't always get you the perfect answer for some of them, but it does here for the theme park. It gives us a nice whole number there. Okay, so two different methods that you can approach. One is just looking at, what fraction of the sample want to go to that place, and then finding that fraction of the total. Or you can figure out how many times does that sample fit into the total amount. So that's what we did there. How many times did 30 fit into 195? And that meant that we just had to scale them up and multiply them all by 6.5 to get our total there. Now for the finishing part here, it does obviously state any assumptions you made and explain how this may affect your answer. I'm not going to write this down, but essentially we are assuming that the sample is going to represent the 195 students. Now obviously, and probably in real life, that's probably not the case. It's very unlikely that exactly 1/3 are going to want to go to the theme park. But in terms of how this may affect your answer, if we are wrong, okay, there could be more students that want to go to the theme park, and likewise there could be less students that want to go to the theme park, okay? So we are assuming that the sample represents all the students, and if we are wrong, there could be more or less students. And actually thinking about real life, it's more than likely there are going to be more or less, okay? But it gives us a good estimate in terms of how many students want to go to the theme park. Now when it comes to scatter graphs, we've got a few things to have a look at. We need to have a look at plotting points, we need to have a look at drawing lines of best fit, we need to have a look at their correlations, which we'll talk about later, and also making estimates off that graph. So we're going to kickstart with these in parts, and there's quite a lot of words in scatter graph questions, so you'd always have to take that into account. You just need to read through these questions nice and carefully. And for the purpose of making this video a little bit shorter and a little bit easier to follow, I've gone for scatter graphs that are already plotted in the majority of those points for us, just to reduce the amount we actually have to do on screen and the time you have to watch me plotting points, as I thought that might be just a little bit boring to follow along with. So anyway, let's have a look at this question. We have the scatter graph shows the marks of 12 students' tests. And if we have a look at the graph, we can see we've got the science marks going up along the y-axis and the maths marks going along the x-axis. And it says here the table shows the marks of 2 more students, and we have 2 students here where we have someone that gets a maths mark of 12 and a science mark of 14, and then we have another student below there that gets a maths mark of 17 and a science mark of 20. Now in part A of the question, it then says show this information on the scatter graph. So we need to plot these 2 points. So we'll start with that yellow one there. We've got a maths mark of 12, which we can find down the bottom here of 12. And then we're going to go up to 14, and we're just going to follow what they already have, which is just putting a little X on that point there. For the one below them, we have a maths mark of 17, which is over here, and we're just going to go up to a science mark of 20. So following that line nice and carefully, you can always lay your ruler down if it helps, just to make it a little bit more accurate. And there we go, that's right at the top there. So there's our 2 points plotted, and that's part A completed. Now before we move on to the next part, there's something that I would advise you to do no matter what the question is asking on a scatter graph, and that is to draw your line of best fit. Do check to see if you have to plot any points first, as that might almost change your line of best fit slightly, but always draw a line of best fit. There is very rarely ever going to be a scatter graph question where you don't have to draw a line of best fit, so we're going to draw that in straight away. Now I don't have a ruler here to use on the screen, so I'm going to draw my line of best fit as best as I can. But just thinking about a line of best fit for the moment, a line of best fit is almost exactly as it sounds. It is a best fit going through the points. It's not an exact line that's necessarily even going to go through a single point. It's just going to go in the general direction of the points. Now what we could do is we could just go for it. Okay, so I'm just going to draw one in as I think would be relatively okay. So there we go, there's a line that's pretty much going through all the points. But when it comes to a line of best fit, everyone's is going to be ever so slightly different, or can be ever so slightly different. Because I could angle that ever so slightly more, let's think of how to phrase this. I could make the gradient slightly less or slightly more. What I mean by that is if we get rid of that one, we could have it going maybe like this. Or I could get rid of that again, I could have it going slightly higher up, maybe like this. Okay, and both of those lines, or all of those lines there, would be absolutely fine. Now the general rule is you want to have about the same points above and below the line. What I mean by that is these little crosses we have on the graph, we want about the same above the line as below the line. Now you don't have to rigidly stick to that, but we do want to get it in that sort of direction. Okay, so having a look at that, what have we got? We've got 1, 2, 3, 4, 5, 6 above the line, and 1, 2, 3, 4, 5, 6, 7 below the line, with a few of those being very, very close to the line. So that would be absolutely fine. You don't have to be too stressed about getting this line absolutely perfect. Obviously what we don't want to see though is a line going in the complete wrong direction in the complete other way. Okay, that obviously would be incorrect there. We do want to get it in the general direction that those points are going in. So we'll get rid of that one. There's our line of best fit. Now we can have a look at part B, and it says what type of correlation does this scatter graph show? Now there are three types of correlation really. We have a positive correlation, we have a negative correlation, and our third one would be no correlation. And it's quite unlikely that you'd be asked a question on a no correlation scatter graph, as there's not really much that you can do with them. But we will primarily, and we will be focusing only on positive and negative correlations in this video. Now this particular graph here we have is called a positive correlation, and if we imagine that we were sort of standing over here, it's almost like we have to walk uphill. Okay, so if we're standing over here, it's a bit of a silly analogy really, but if we are going from the y-axis and we are walking to the right along the x-axis, we'd have to walk upwards, and that right there is what we call a positive correlation, where the line is going upwards. If it's sloping the other way, like that little line I drew a second ago, that would be our negative correlation. And it would just kind of mean we would have to go downwards down the line, obviously using my little person analogy there. But let's get rid of that. So we have two options. Sloping upwards is going to be a positive correlation, and sloping downwards is a negative correlation. So in terms of this question, what type of correlation does it show? All we would have to say is positive. Okay, now this is just my personal preference, but I always like to stick that word correlation with it. Just in case it doesn't say the word correlation in the question, we would be wrong then just to put positive. If it just asks what sort of relationship it had, we would have to say positive correlation. So do get used to just including that word and just saying a positive correlation. I've not got much space there, so I'm not going to write it in. But had it have not said the word correlation, we'd have to make sure we write that in. So there's another key little point there. You don't want to be missing a mark for not writing that word. As it does say correlation, I'll just write the word positive. Now on to the last part. It says another student's mark in the maths test was 15. Estimate the science mark for the student. Now this is easy enough. All we need to do is find that information on the axes. So we have a maths test was 15. So if we go along the maths marks and we get 15 down here, all we're going to do, and do show this working out, we're going to get a ruler and we're just going to go up to our line of best fit. And this is where everybody's answer will slightly change depending on your line of best fit. And once we hit that line, we're going to go across and read that off the axes on the left. Now I've kind of sloped up a little bit there, and again we do want to make this accurate as possible. I haven't got my ruler, but we'll do this with a ruler. There we go, and we get a mark of 17. Now depending on your line of best fit, it might have gone just over 17, so it might have been 17.2, it might have been 16.8. Whatever value you have, you read exactly what it is off the axes there. So for me, for my little estimate there, I'm going to go with 17. You don't have to necessarily round it to the nearest whole number if it does go over or just below. You're just going to read it exactly as it is on the axes. So for that one there will be a little range of values that people are allowed. So maybe it might range from 16.6 to 17.4, something like that. Okay, but obviously you will get the marks for this sort of question as long as you show this little dotted line and exactly how you got your answer. That will take into account that if your line of best fit was just slightly off, or you've done it a little bit in the wrong direction, that you did know what you were doing and you're using the correct method to find your estimate. So there we go, that's pretty much everything to do with the scatter graph. There is one more thing that we could have. We could actually have to plot maybe a point that doesn't fall within this general trend here. Let's say, for example, it said somebody got, I don't know, 18 marks on their maths test and 14 marks on the science test. And if we plot that point, that would be just here. Now that would be called an outlier. Okay, something that doesn't follow the general trend. And it might ask us about that. It might say, you know, why was this point out of the range, or give a reason why this point was over there. We might just have to give a little logical explanation, something along the lines of, and it can sound really sort of silly, but you might just say, well, perhaps that student had a bad day on the science mark, or perhaps their maths is just a lot better than their science. Anything that's logical that fits into a reason as to why this point might fall out of place would be absolutely fine. Obviously nothing silly there, but just thinking about something logical in real life. Likewise, we might be asked to predict somebody's mark that got 21 on their maths mark. Now this graph obviously doesn't go up to 21, maybe 21 wouldn't exist on this test, maybe it only went up to 20. But let's say the test was out of 30 and it said to predict somebody's science mark that got, I don't know, 25 on their maths mark. Now we would have to say in that situation that we couldn't, because it's outside of our data and it's outside of the graph, so we couldn't actually make that prediction because we don't have any data in that particular range. Okay, there we go. So that is the end of the video. Seriously well done to you if you've made it this far. You have just managed to cram in an awful lot of revision towards your exam. You should be really proud of yourself because this is a really long video. It's certainly the longest one I've ever done. So before you go, I just want to again wish you a massive good luck for this exam. I really do wish you the best of luck, and please, as I said at the start, don't forget to sort of leave some comments in the future as to how you've done, because I always like to know how everybody's done. But again, I wish you the best of luck, and yeah, hopefully see you for the next one.